What's up, everybody? Happy 7 o'clock on a Thursday. Today's Thursday. Yeah, happy Thursday, everyone. How you doing tonight? Just getting all set up over here. Hope everyone is doing pretty good. Oh, you can't see that. What's up, Flylit? What's up, Molo? Fox, Mahale, how you doing tonight? Appreciate it. Thank you. What's up, Sand? I can see Sand. I don't know what's after that. What's up, Media Noche? 88 Opus, how you doing tonight? Sharky, what's good, bro? How you doing tonight? Our man, how you doing? Now or later, I like it. Yo, Sicko 93. You lost the game today. That sounds unfortunate because that's your name permanently, so you must lose the game every day, and that's kind of sad. Unless you make a new unless you have two, maybe you have a I won the day channel as well, or account as well, that you choose when you do win the game. What's up, the greatest Rob, Mickey, Gray the Knight, what's that, Christian C, Triquetta, how's everybody doing? Hey, beautiful 89, how you doing? Miss Great. All right, tonight, I hope anyone who was a part of Horizons last night isn't too burned out from yesterday. I know it was a lot. Tonight is going to be, we have a lot of topics tonight, but I do think we should be able to get it through it pretty quick. We're going to start really explaining some of the stuff you've already seen us do so far, with some variables, and we're going to learn how to output things to the screen, and we're going to learn how to take input from users tonight, and what those concepts are like. And we're also going to learn one of the most important technologies to software development, which is Git. We're going to dive into Git. We're going to learn a little bit about GitHub, so that we can use it for the remainder of this course. It will be an integral part to the remainder of the course. There'll be some code you need to clone and things, but yeah, wish I was on a different time zone. Yeah, I'm sleepy as well. Like, I did not get a lot of sleep last night, unfortunately, but no big deal. You guys usually energize me, and we'll get through this pretty quickly today. It should be fun. Yeah, Horizons was a lot. I know. 2 finals today. What did you have the finals in, real deal? And how do you think you did? Which language? Tonight, I mean, as throughout the most of the course, tonight we're going to see some concepts of all of the things in both Python and Go. And tonight you're going to see immediately why, like very, very, very soon, you're going to see why we're not sticking, well, not why we're not sticking to one, but why I said before that learning a statically typed compiled language can be intimidating, and it can be off-putting, and it can be a reason why people stop learning. And you'll see that with some of the simpler examples tonight, how much more code it takes inside of Go. We've already seen it a few times before, and Go is considered to be one of the easier ones to write, but it'll be pretty interesting. But we'll be doing stuff tonight with both Python and Go, maybe a little bit of JavaScript as well, but Python and Go mainly. Let's pull this up. Let's switch to the Academy view. Whoops. Let's I'm going to, do we need the whiteboard tonight? We might need the whiteboard tonight when we get to Git, hopefully. Let's plug it in real quick. It might not work. I know that OBS does some weird stuff with the inputs if you don't have them like plugged in at the start of OBS, but we'll see. We'll try it out. We'll see if the whiteboard loads. If not, we'll see what we can figure out when we get there, but it'll be a little while. You finally, oh, D Jackson, that's what's up. You finally got it all set up. Databases and a programming language, and I think I did good. Yeah. Okay, that's dope. What I'm assuming, I guess all the classes are still relational databases most likely, but that's dope. That's dope. I'm glad you're so it sounds like you're in a comp sci program or an IS program, like information systems. That's pretty dope. How long do you have left in your program, or are you just taking classes? Sean from LA, what's up? We in here. Python exercise, enjoying the exorcism. Hello world. I'm already stuck. Perfect. We are maybe we will hop on exorcism tonight. Maybe we will. Let's see what we have time to do. Maybe we'll hop on there to get everyone kind of introduced so that you can go off on your own if you'd like. I forget how to path my VS Code and terminal in Linux. It should just work. But if not, we can figure out how to make that work. All right, what are we looking at here? Let me pull up Notion for you guys as well, so you can see what the roadmap is a little bit. Why am I not logged in? Let's log in. Actually, let's pull in the real Notion from my Windows desktop. Apprentice. So tonight we're going to be learning a little bit. I know it's tiny. Variables, output, input, and source/version control is going to be tonight. That's gonna be fun stuff. It should be a little bit of should be some new information for you. I think the concepts are consumable in the amount of time that we have. I don't think this will be overwhelming. I think today is probably going to be just right, like just push you to the edge of like, all right, I was able to get the first set of concepts, but as we dive deeper into Git, you might start to be like, okay, I think I know what it is, but like, I don't feel comfortable using it, and we'll grow that confidence over time. But then we're gonna dive into data types and data structures already next week. So it's gonna be a pretty quick moving. So we'll get right into data types and structures. We'll also start solving some problems next week. We won't dive into algorithms quite yet, but we'll start like solving some little problems there, and we'll just keep picking up the basics of what we need to do. There'll also be a number of computer science topics and theories sprinkled throughout there as well. Yeah, but this is just kind of the way we're going. So take a look, and again, one day I'll get it up, but I just need some time. But that's what we'll be doing. And let's get everything pulled up. I'll close this. Let's get the slides out. We do have slides tonight. I think we have a fair number of slides actually tonight, but I'll get everyone the link. Let's see. Share. Every time I have to do this, it's like the first time I'm doing it. There we go. Anyone with the link? Copy it. I gotta say it out loud or I'll forget. All right, is the Apprentice at Markdown? What? I'm not sure what you mean by that, deCoded. The Apprentice app Markdown. Like, if you're talking about the site, the like website where you get all the information from, is it Markdown syntax? If you mean like the Mastermind IO site, yeah, it's Markdown. I think that's what you're referring to, but probably 2 more semesters, the rest have security classes. That's dope. What's your that's pretty cool. Security classes at the end seems pretty interesting. We start already? No, we are about to start right now. It's, what is it, 7:08? Perfect. We'll give people 2 more minutes. Let the good times roll. So just, I want you to, the information tonight is going to be the coding concepts that we're going to go over. I think you'll be able to understand them. I think it'll be fun for you to mess around with them, especially if it's, you know, you're really just learning. It'll help you kind of get going. But I think you'll be able to understand the Git part is going to be great. Git is one of the skills that is most sought after. I can't tell you how many people I come across who've learned how to code for a while, but don't have decent Git skills. It is a very valuable tool to have, especially when you're working amongst other people. It'll help you contribute to other projects. So, all right, let's do this. So, variables, input, output, plus get good, hashtag get good, an intro to version control. So this is all one piece right here. You're gonna learn all about what version control is, so don't sweat that. A lot of items tonight, you know, it seems like a lot of different things, but these 3 we should be able to get through pretty quick. We're gonna do lots of examples. Repetition is key, but some things change. So that's a little nod to variables, which you're about to learn about. We kind of ignore the stuff in the middle here, but some things change, track them. And that's what Git and version control will help you do. So first thing that we're gonna do is we are gonna learn how to display output. This is very common. One of the things that you're gonna wanna do when you're coding is to display output. Is you're gonna wanna get information to a user to be able to consume that information with whatever it is. And so we've done this plenty of times. and we're going to learn about some of the different ways to do it tonight, and we're going to do it in both languages, but just understand what's happening here. So what is so when you want to display output with a coding language, you just print it, and so this is ignore the title a little bit, but I want you to, I say that just to get across to you what's kind of happening here. So what we're doing when we display output is we are commonly what we're doing in this course, and what you're usually doing, is you are displaying text. You are sending data to something called standard output. Standard out, you're going to see it a little bit later. There's a few abbreviations for it, depending on what you're doing, but there's one main Linux one that we're going to be using tonight. But it is sending information to something called standard output, or in our case, it's going to be the console. So we've been working with the CLI, we've been working with the console, so that's where we're going to be sending this information. Whoa, John Wonton, thank you so much for the gifted subs, the 10 gifted subs. I really appreciate that. Dang, you get VIP for that, /VIP. What is that? John Wonton coming in hot early. There we go. You're part of the VIP. Welcome to the VIP club. That's dope. I really appreciate it. Thank you so much for the support. What's a tier 1 gifted sub? That just means you'll no longer see any ads on this channel. It also gives you access to the emotes. It also gives you access to some subscriber only things as well. So yeah, you should thank John Wonton. That cost him money. He came in and flexed a little bit on y'all, but it's a dope flex. That's my favorite type of flexing. But awesome, I really do appreciate that. So what we're gonna do is we're gonna learn how to get this information out to everyone. To everyone who needs to see it. So you've seen us do it in Python before. We're going to do it with Python right now. We're going to print it out. What we're also going to learn tonight, actually, I didn't want to put it as another thing in the title for you to memorize, but tonight we're also going to be learning about documentation, where to get that documentation. We'll dive into how to read it a little bit as well, so that you know where to reference things from. So Python, we're going to do something called print. In a few languages it's print, in both Python and Go. The tool that's going to allow you to do this is identified via the word print, because that's a good word for you to understand what it's going to do. So what I have here up top is print for Python, and so this is a function, but we're going to learn about functions later. And whatever you put in these parentheses right here, it's going to send that out to the standard output. It's going to send that out to the console. And you saw us do some stuff with printf, but let's mess around with it in Python, and then we're going to mess around with it in Go a little bit. And so feel free to go through and do this with us, because this will be fun. So I will do it in, you know what, I'm going to do it in VS Code. I'm going to do it in VS Code so that everyone can follow along. So go ahead and open up VS Code right now. What you're also going to learn right now is how to run we did a little bit last time, but we're going to learn how to run, a Python file or whatever. You can either open it up and you can open up a folder where you would like to save this. Whoa, yo, what is happening? What's up, Zosam32 with the gifted subs? Oh my gosh. Respect. I truly do appreciate it. Also, I really thank you giving everyone a way to not have to see those ads and to be able to participate in so many different ways. Thank you so much. You also, again, that'll always get you VIP. Zosam32, you're much appreciated. We'll have to do something special for all you special people one day. I really do appreciate it. So while you're in here, go ahead and if you just open up Visual Studio Code, it might show you a bunch of stuff here. Just go ahead and open up the folder. Whoops, that doesn't open it up. This creates a new folder or creates a new file. Make sure you are where you want to be. First, make sure you've opened this workspace up in the place that you want to be. So the way that you would do that, I think, is you do it through here, like open up folder. So file, open folder, and then it'll take you to your normal file browser, and you can tell it where to open up. So maybe we want to go into documents, and we have a deCoded directory already, and maybe we're gonna do more examples here. So I'll click OK here, and you can see over on the left there were some things in this file. So go ahead and start up either open up a folder or start a file. The name, the extension of a Python file needs to be .py. So you can click over here for new file. We're going to start doing this in Visual Studio Code right now. Later on, as we create new files, we'll be doing it through the command line, so you can start to pick up some of those Linux skills. We learn how to do things in Linux. Feel free to create it that way if you'd like to start, but we're going to start to slowly ease that into our workflow so that we can start to learn all those Linux things as well. So let's go ahead and create a file called print.py. That's what we're going to call it, print.py, and go ahead and enter. And over here, our file is going to open up. You know what? I'm sorry. I care about things looking kind of good. My theme of choice in Visual Studio Code, I don't really use Visual Studio Code that often because I'm a Vim user, but I like this Monaco Pro theme, which I think costs money, but it lets you install it. I think it's freemium. Maybe I'll support it one day. All right, not important. You don't have to do this. If you do install a theme, you can install themes over in the extension section. And if you want to install them, hit Command KT or Control KT if you're on Windows or Linux, and it will allow you to pick which theme you want to use. It's freezing. Hold on, let me monitor. So yep, go ahead, Sean from LA, just create a new file. That's all you got to do. Let me pull this metrics up, and let me actually pull up a live feed just to make sure that things are going decent. Nope, accidentally clicked on the chicken stream. If you guys have never been to the chicken stream, it's surprisingly interesting. You get to feed the chickens. You get to, interact with the chickens, make some lights go off. That's pretty dope. I can't open your video. It does look frozen. No, it doesn't. It doesn't look frozen on my end. All right, cool. Yeah, it looks good for me. But yes, correct. This is a Python file. I'm sorry. Let's get on track. I'm all over the place right now. It is a Python file. So .py will make it a Python file. So go ahead and just click again the little thing up here to create a new file. Call it print.py or whatever you want to call it. Doesn't really matter what you call it. The name of the file never matters. That only matters when you're actually going to run the file. So call it whatever you want, whatever will help you remember it. But we're going to be printing out some stuff. So we're going to go ahead and do this. So first thing we're going to do is just reinforcing some of the things we've touched. Comments. So comments are a way for you to put information in your code about either what's going on or to make notes. It's a way for you to write a line of text that will not be interpreted by the interpreter. And in Python, what does Python use? Hashtags, yeah. So the # hashtag, whatever you want to call it. So on line 1, I want you to go ahead and enter in a hashtag, and let's just put a little information about what we're doing. And whatever will help you learn, like it's like a little note for yourself. And we'll say, this is going to be an application, well, not even an application. It's going to be a program that teaches us to display output. Just so you know what it is. A lot of times a README or something will just do this, but code commenting is pretty good. We'll talk about later on as we're actually writing things. Probably when we get to the algorithm section, we'll talk about how to properly use comments to, really be effective and kind of the best practices around comments. But yeah, can't get Visual Studio. So this is Visual Studio Code. You can also download some other items like other free items like so that's Visual Studio. What you want is VS. I think I thought it was a command last time too. What you want actually is not that. What you want is Visual Studio costs money, I believe. VS Code. What's the? You want code.visualstudio.com. This is the free one, and everyone can get it. There we go. Okay, so in VS Code, Why is my mouse integration not working? All right, so again, once you have VS Code open, all you got to do to open up a new file is over here. Make sure you've selected the Explore section in the top left over here, and go ahead and hover your mouse over the file tree, and you should see this new file thing right here. Or you just go to File, New File. Just like Microsoft Word, this is not a special program. Just like any other text editing program, again, most likely Microsoft Word or Google Docs. If you want to create a new thing, if you want to create something new, File, New File. That's all you got to do, and then just type in the name that you want, and you can save it as normal. Yes, if your comment is a different color than mine, no big deal. That it will. The color will depend on your color scheme. The default color scheme probably has it to be a different color. Usually it grazes out a little bit and like dims the color a little bit to kind of visually show you it's a comment. But yeah, just make sure you have a single hashtag here. And I think you need a space in between. No, you don't. Okay, so printing. All you have to do to print something out to standard output is use the function print in Python. So a lot of languages, it's something similar to this, but this is something called a function. It takes an information, and that information that's going to take in is this stuff that is in the parentheses. You need to have parentheses for it to run. The parentheses are essential, and whatever you want to print out needs to go inside here. So we're going to print out some strings. Remember, strings are words and text and phrases. So we're just going to print out whatever string you want. You can just say, this is our first print ever, or something. Whatever you want it to be. Just go ahead and type it in there. So the word print, open parentheses, double quote, put the information inside of it. Close the quotes, close the parentheses. So this is all you need to be able to display things to standard output. You will print things all the time while you're programming. So this is an important thing to know. Go ahead and save that file. The way that you save it is either File, Save, or again, just like Microsoft Word, Control S or save, or Command S if you are in Mac. If you're on a Mac, do you put a colon at the end of the first line? That is a great question, Jess Machine. I think you can put a colon there. Semicolon there. I'm pretty sure you don't need semicolons in this version of Python. I don't think you've needed them for a while. Which you can't. I don't think it'll hurt if you put it there. Maybe it will. The reason you don't need to do it is because languages have kind of updated themselves, or they've been modernized to interpret those real time. It'll kind of stick it in the background, but it will work with no semicolons. I never put semicolons in. So when you're ready to run it, again, you can hit the play button here. But again, as we move forward in this later on tonight, we're gonna stop using this play button. We're gonna use it tonight. And maybe at the start of the first time we do something every day, we'll use the play button, and feel free to use it. But I want you all to get more comfortable with Linux, or the command line, at least, maybe not Linux, but the command line in particular, and running files from there. And so you can do everything from inside of here. You don't need to open up any other programs. What we can do is, now that it's here, well, we'll just run it first, and then we'll go into the terminal. So when you run it, it'll stick out here, and it'll give you some text. It'll give you a bunch of stuff. Remember, we learned that these are file paths. You see it starts with the slash. So in your mind, you should be thinking, you tell me what it starts with the slash. So that should tell you something about this line here. Same thing here, starts with a slash. It should tell you what type of file path that is, but not important to the running the code. It's just giving you some information about what it's actually running. But this is the output here. This is our first print ever. And it goes ahead and it sticks it out here, which is nice. And it opens it up and it runs it right in your terminal. Absolutely, absolute path is what it is. That is an absolute path. It's the full path to the file. So really, I'm gonna run, so this is the command that it ran to execute this print file, this print.py file. It ran, my computer ran this entire thing. Whoops. So it ran this whole command, and so if I run it again, it'll go ahead and it'll print. So all it's doing is referencing the Python interpreter. So we know this is an interpreted language. It's referencing the Python interpreter. That's what the first part is. The first part is user bin Python 3. That is where Python is located. And so it's calling Python, and then it's calling the file that it wants to pass into Python, or wants Python to interpret, which is home, mastermind, documents, decoded, examples, print.py. Now, that's ugly. Like, this seems like a lot of work. When you want to run code, you don't want to type that in every single time. That's very, very annoying. You wouldn't want to do that every single time. Your computer probably will allow you, we talked about this when we installed Python. You can probably type in whatever it calls Python here. If it's Python, you can just use Python. If it's Python 3, you may have to use Python 3, but type in whatever this is. So I'll type in Python 3 and the name of my file, because the terminal will automatically open up where your file is. So this is actually the relative path to it. So same thing. These are referencing the same file because I'm in the right directory, and I hit enter, and it goes ahead and it prints it out. So the way that you run your file is going to be Python 3. Type in Python 3, and then type in the name of your file. That's how you're going to run a file. Call Python, tell it what the name of the file is you want it to interpret it, and it will work. So yeah, so that is our first print. Let's see if we can all get there real quick. Let's see if we can all get on the same page and be able to do that. So get that typed in, make sure you save it, and go ahead and try to run it. So let's see. Do I put a semicolon? Nope, no semicolon. There's also an autosave option. Yes, there is an autosave option. I don't know where it is in VS Code. Again, like I said, I'm not a VS Code user. Autosave, it's right here. Makes it really easy. See, maybe I should be a VS Code user. I'll click autosave, and so maybe this will be more like, let's see what happens if I type in like test, and what happens if this should break it. If it's saved, this should break. It did. Cool. So it is auto saving. Nice. So there's an autosave option in the file list. You can click autosave and it will autosave your files for you. Really nice. So thank you for that. Mine works with no semis. Oh yeah, yep, no semis, absolute paths. For some reason, I don't have a play button. Interesting. That may be because your computer does not know where Python is. Oh, that's really annoying. It's gonna say no pip thing is installed. I'm going to, I'll leave it there for now. It'll just keep telling me over and over again, which is going to be really annoying, but oh well. Windows Python 3 doesn't work, only Python. Yeah, that's completely fine. So the reason why it's Python on some people's computers and Python 3 on other people's computers is because Python sets up something called an alias. So Python doesn't work for me, but basically what it ends up doing is when you type in just Python, your computer has something in the background that says, hey, whenever I get Python, go ahead and basically point it at the location of Python 3. So Python 3 is the actual name of the executable, and that's what we'll do it. If you don't have Python 3 at all, you can use Python 2 for everything that we're doing, to be honest. But if Python works, use Python. If Python 3 works for you, use Python 3. We were trying to think of some cool ways I was working with somebody, we were trying to think of some cool ways to make sure everyone could do the same thing. The only way to do that is to use, if we all used an external platform, but I think it's more important in this class for you to fight through getting everything set up locally, because these are things that you will have to do. If you're having a lot of problems and you don't want to worry about messing with Python, last time someone taught us about REPL.it. I think that's what it was, REPL.it. So, and you can just click start coding and you can open up a Python workspace. So go over here if you are having trouble getting Python to run at all, and you can head in here and do the same things. And then later on, you can go back and make sure your Python is set up properly, but you can just go ahead and type in print here and hello, and they have a play button right here, and it will all operate over here. So if you want to go there, feel free. You're not going to be missing out on any of the concepts tonight if you should do it there. What command should I use in Linux for this? You should use Python or Python 3. It's going to be Python or Python 3 for whatever. Yeah, you have to see which one. Like everyone's computers and package managers sets up Python in a different way. So yeah, try Python or Python 3. And if neither one works, if you're on Linux, you can absolutely do that. You can install Python 3 if you want. Both Python and Python 3 are getting error messages. Do you have Python installed at all? If you don't, K-Cole, let us know what operating system you're on, and we may be able to help you out a little bit. But so that sounds like the path may not be set up. If you're on Windows, that might mean you didn't check the little checkbox. iOS, I'm gonna assume you mean Mac OS. If you're on iOS, I have no idea how to set that up properly. So how would you set up the path for Linux? And so do you mean I don't know if I want to dive into pathing right now, but so everyone, we've talked about file pathing before. The reason why you can call Python by itself, Python does not exist where we currently are. It does not exist in this directory. So if I do an ls, there's no Python here. And remember, I said everything in Linux is just a file in a folder, but it would be really annoying if we had to type in the full path to everything every time. So there's a concept in Linux, and really on everything in any file system, called a path. And what the path does is the path variable basically holds a list of locations that can be accessed, that basically loaded in, that can be accessed without having to type it out. So I'll show you. If Python does work for you, there's going to be a little bit of interesting Linux knowledge. If Python does work for you on your computer, try this. Whatever command works for you, whether it's Python or Python 3, try typing in which Python. So whatever one worked for you, Python doesn't work for me, so nothing will happen. But if I type in which Python 3, it gives me a full path. And this full path right here is where Python is installed at. It is the location to the Python executable. And so that is where, so you see /user/bin. If this, basically anything in user bin, I can actually call by name. So if I look at the things in there in user bin, it's gonna be a lot of stuff. There's a bunch of stuff in here, but all this stuff that's in user bin is a part of my path. /user/bin is a directory that is a part of my path. So anything that's in this directory, I can call it by name. So something like x sub pp. I have no idea what that is. But if I wanted to use it, I could do x sub pp. And if I ran this, I shouldn't do it because it might break everything, but it doesn't say command not found. It finds it because of that path variable. I don't want to teach you how to add things to your path right now. I do think that is something you should, because people will go venture off and try, and we will break a lot of people's computers, or possibly break a lot of people's things. I think that's something we should work through each other in Slack or Discord about. But yeah, if it's not a part of your path, you have to find out where it is, and that might be the hardest part, is finding out where it is first. There's a number of ways to do that, but again, it's using some Linux foo. But again, that was a little bit of extra information. So don't, if you're like, man, I don't understand this path stuff at all, don't sweat it. What's important, don't even worry about that. Head over to REPL IT. If it's not working for you, head over here, and we want to understand the concepts of printing out data. So we were able to run that, and we were able to print this out. This is our first print ever. So pretty simple here. We can also do, and we can even just go up to our example, but we can also grab, we're gonna create a new file here, and we're gonna do a print.go here as well. And we'll put them side by side so you can see them side by side. And our print.go, we're gonna do the same thing. So we'll put another comment at the top. So close this. In our print.go file, so the same thing you did before with the Python file, you can make a Go file as well. And we'll put a comment at the top. Comments are different in Go. To start a comment, you have to do a / instead of a hashtag. But the Visual Studio Code and most things give you a chance to easily be able to. Hold up, I'll hit you in a second with that. But Visual Studio Code allows you to automatically insert comments pretty easy. So if you're working on a programming language and you're not sure what the comment character is, if you hit control, if you hold control and hit the / button, hit /, which is the one right next to probably your up arrow, but it's on the lower row. But if you hold control, hit /, it will automatically insert a comment. So you don't need to, sometimes you don't need to remember what they are. But yeah, Sean from LA. Appreciate it. Oh man, that is an extensive list of gifted subs. Also, everyone who does receive these gifted subs, I encourage you, reach out, make friends with Sean from LA, make friends with the person who gifted you that sub. I really do appreciate it. You got to get VIP. Let's do it. I need an auto VIP button, which basically this is what it is. Sean from LA. Really do appreciate you, man. That's great. Everyone's so kind. The love, I feel it. I feel it, man. Even after the nip slip, you guys stuck with me. Even after the nip slip. But okay, so we have a comment here, and we can put the same comment here. We can say this is gonna be a program, be an app that displays output. Bottom here, so displays output. And in Go, everything's a lot different. There's a lot more pieces of Go. So I'm gonna put the for Go actually. So you can either do it in REPL.it, or you can go to the Go Playground. So I gave you all some resources in the classroom. There is a Go Playground. I think it's or it's Playground. I'm just gonna Google it. It's play.golang.org is a Go Playground. So if you want to mess around with Go while we're doing stuff tonight, feel free to go here and mess around with it as well. But again, I'm going to start doing everything inside of VS Code, because that is where we're going to be doing things more and more. I'm going to do things less and less in here because I want to encourage you to go learn how to, you're gonna have to set these things up. You're gonna have to be doing these things in files. You're gonna have to be running these things manually yourself. But yeah, right now we're just learning how to actually display output. So Go requires a bit of setup for anything to be able to run. That is why here on the Go Playground, they already have a bunch of stuff. We've seen this before, but this is really the only line that's needed to print something. The rest is all set up. So we'll actually copy and paste this, save ourselves a little bit of time. And so this is the line to print stuff out. So we said a lot of things use print. Let's see, we're actually gonna close this over here. Let's see some cool stuff real quick with this print line. We're also gonna look at some Go documentation in a second, also some Python documentation. But we're gonna run this. So I'm gonna save it, it auto saves. And you see I have no play button here as well. I see the play button missing. But so we're gonna have to run this by hand. The way that you can run this in the terminal is you click terminal, you click new terminal. All right, it's gonna open up the file where we are here. The way you run a Go package or a Go file is you do go, run, and the name of the file. So print.go is what I'm gonna need. And I'll pull this back up so you can copy it in a second, but I want you to see it print for a second. And it says hello playground, and we can put whatever words we want in there. But see how it's the same thing. It is a function. It's a word here, it's open parentheses, you put the string in between and you close those parentheses, and it goes and it prints those things out for you, which is super nice. And we can put whatever words, 1, 2, 3, 4, and I can just do that again. I can run go, run print.go, and it prints out whatever I stick in between here. So this is the act of displaying output. This is getting output to standard output or to the console. So this is yeah, we'll talk about standard output in a little bit, but that's all we're doing. And again, it's a common paradigm. You've probably tried to run some programs when we did some of the Linux stuff. When when you're doing things like ls in here, when you're running things like ls, that is printing. These things are getting printed to your screen. They're getting output to your console, and that's all it is. That's all displaying output is. But there's a lot of caveats with displaying output. There's a lot of different ways that output reacts. There's different ways that different data types react. So throughout the entirety of this, we will be learning those little things, and we're gonna learn some of that right now. So Python only provides you a single print, a single way to print things. So this print is what you're going to need, but it allows you to do some other things like format print. So we saw yesterday or last class that you could kind of format text with the F. We're not gonna worry about that at this moment, but we're gonna come back to printing and formatting, and after we learn variables in a second. But there's also different ways to print in some languages. So while Python presents you this way to print things out, display output, Go presents you things like this print ln. You might say, what is ln? Like, why does one say print, but this one says print ln? So print ln is actually a print line. It's actually to print a line. But Go does have something called print as well. So you can just use print and it'll work. But let's see what happens when we run this. So we're gonna new terminal. We're gonna type in go, run, print.go. And when I run it, get a little, see everyone, this is why we had a long conversation during the Linux thing about why I do not like ZSH. This is why. I was trying to prove to you a point, and it did not do what I wanted it to do. So what we're gonna do is I'm gonna run it again. So just ignore that, but go, run, print.go. And when I run this, doesn't this look weird? It says hello playground 123, but then it just puts my name and stuff right next to it and starts the next area down here. That's kind of weird. So run it. It's all jumbled up, but if I put print ln back in and I run it again, it doesn't do that. You see here how it doesn't just stick everything to the end. It's a lot cleaner. The reason this is because print line in Go actually prints a line. It prints a line of text, and then at the end of it, it says, hey, I know you want this to be a line of text. I'm gonna go ahead and go to the next line. I'm gonna insert what's called a new line character, and it's gonna go to the next line. So it gives me a little bit of space here. So it helps with formatting output as well. There's also a couple different other print items that you can use. So with whatever language you're using, there may be multiple ways for you to get that output to the screen. Usually there's gonna be some type of print statement. There's gonna be some type of either print or write command to be able to get that output to the screen. How would you find out what those things are? And let's look at both the Python documentation. Actually, for Python, I'm going to point you at the real Go documentation. For Python, we're going to go to W3 Schools, and I'm going to send you the link here. So we went through, we're not gonna go through installing Go right now and adding it to our path today, because that was it was to try to do that as a part of the homework. I can run through that at the end. If you're trying to do Go right now, do it from play.golang.org or from repo.it. The key tonight is not to get the things installed. I know I understand it's frustrating. The key is to understand how we're printing output, how we're and how the languages do the task that we're going to be trying to learn tonight. And doing that will take a lot of time. Everyone's computer is different. So again, I would actually go back to the first or second class. There's some instructions in there. There's a link to getting it installed. I would try to head over to the link and see if you can follow the install instructions to get that done. If you're having trouble, again, I would reach out. Again, explore. I know it's scary. I know it's frustrating that I'm not giving you the answer. It's okay. feel comfortable, explore. You won't get left behind by not being able to run it manually locally. I promise you, I'm not going to be leaving you behind. Is there no run button for Go scripts in the top right corner? I don't have one either. I like I said, I actually don't use VS Code, so it's probably not that at all. It's probably has to do with some configuration. So compiled languages work because they work differently than they work a little bit differently than interpreted languages. We probably have to set up like a target for it, or like maybe I have to set up a run command. I might have to configure the run command for Go in here. I might have to tell it where Go is living. I may not be able to see where the Go executable is. It's a possibility. I'm not sure which Go. Yeah, so it knows, my computer knows where it is, but it seems like Visual Studio Code does not know where Go is. But yeah, but I don't know. But yeah, seriously, head over to REPL because it'll give you some nice color highlighting. The Go Playground does not give you any color highlighting, but head over here and try to do it in here as well. And I think this will give you, like, I think if you click on Go, I think it'll give you the whole setup, so you don't have to worry about typing in all the extra stuff. I believe it'll give it to you. So it gives it all to you. So this is your print function. So you can try the thing that we just tried. So try just running this, seeing what happens. Try removing the L and the N and running it and seeing how it differs from what you had before. And compare them, go back and forth and see what's different about them. But again, what is different about them is print line will print a line and give you a new line character. So there's actually an invisible character, not invisible. Well, yes, an invisible character that gets put in. We can actually do the same thing here. New lines are very important, especially when you're dealing with. There's gonna be times when I push up code to you. There's gonna be times when I'm allowing you to commit code back to the repositories. We're actually gonna be merging in people's code. One of the problems is, especially for everyone who is on Windows, new lines are a big problem. The line endings, there's invisible characters that end each of these lines. They kind of look like this. Like this is This is a new line character right here. That's why it changes colors. This is an indication to the computer to say, hey, right here, when you see this, this is how I know to interpret a new line, to go to the next line. It's when you hit enter, it's inserting this invisible character. So look down here in your VS Code, there's an LF. And if you're on Windows, it's probably set to CRLF. It's fine, don't change it now, but this has to do, I would actually encourage you all to write that down and to go look up LF versus CRLF a little bit later. Again, it just has to do with the way the computer encodes line endings. We talked about encoding a little bit. We talked about ASCII, and again, Windows will actually encode this different than Linux. So the binary number value for a new line is going to be different between those line endings. So it can be a problem sometimes. It can be pretty problematic, but again, those are all just extra things. What you want to know right now is purely how to print some stuff out. So just go ahead and run the print statement, print out whatever you want, mess around with it, print out your name, print out your age, print out whatever you want to print out. All right, next thing is variables. This is a huge concept. So one concept is that you can get data out to the screen. This next concept is a huge one that spans across all of programming. It's very, very important. You will use these all the time, but it's called a variable. Now, what do we know about the word variable? Think about variable interest rates, or continuously variable transmissions, or think about all the different words or phrases that have variable in it. Variable it just means that this thing can change. It can be modified. It can be different. So variable interest rates change over time. Variables are a representation of a value in a coding language that can change. So here's kind of a little image here, and we've done this before where we set up a variable called name, which is a representation of a value. It's a placeholder. It's the box that's going to hold a value. And so we could tell this we could say that the name variable is equal to Maria. So we could put the word Maria inside of that name variable, and now the value of name would be Maria. Name would now be Maria, but it could be changed later. We could pull Maria out of that box and we could put Aaron in the box. We pull Aaron out of the box and we could put something else in the box. And you could modify the value of that thing. So the variable is the placeholder. It's just a placeholder that stores a value. So let's see what that looks like, because this is very, very important. It's a simple concept. Well, it's a simple it's a simple concept to explain, but it does take some practice of using it over and over again to figure out comfortably how it works with a bunch of different items. But it's all it is a representation of something that's a placeholder for a specific value. So we saw this the other night when we did our name and our age. And the way that you do this in Python, let's make a whole new file. Make a whole new file so that we're not confused. We can keep this one just to be print. And so this one's saved, so I'll close it. This one is for go. Let's go ahead and create a new file over here. Let's hit new file, or let's do it here, file, new file. And we'll call this, oh, it's not gonna let me change it easy. This is, you have to try to save it first. So that's weird. I guess a new file, you have to I had to hit Control S to put the name in, or is there a way? So Control S to save it for the first time. I'll call it variable.py. So variable.py. Remember, that's pretty important. Python, the extension to run a Python program is .py. The one to run Go is .go. Every programming language has its own file extension that you need to know to be able to name the file properly so that it runs. So we'll say variable.py, and you can see here, it puts the little Python thing next to it. In my editor, if you don't have the same stuff installed, that will not happen to yours. Don't sweat it. Just variable.py, and things will be looking good. Once you add that, a variable, again, that placeholder. Python, it makes it super easy to add variables. All you have to do with variables is type, actually, because I never do it in Python, can you just declare a variable? Let me just see something really quick. Don't follow this. I just want to see if this works really quick. And we can look at some documentation. I just want to see if this works, because we're going to talk about declaring variables versus, okay, cool. So variables can be set up by in Python just by calling them by name. So this line right here sets up a variable called name. How do you know that this line has to do with a variable? Whenever you see a single equal sign and you see text that's not in quotes, I know that can be a little bit confusing. When text is in quotes, what is it? It's a string. That's a certain data type. Whenever you see text and then a single equal sign, it's pretty important that you know that it's a single equal sign. This is doing something called declaring a variable, and we're also setting a value to the variable. So we are creating a variable called name here, and we're setting the value of that name equal to Aaron. So we're creating this box, we're creating this placeholder, and we are setting the value of it equal to Aaron. So now whenever we refer to our name, it will actually be looking at the value Aaron instead. So it won't print out the word name, it'll print out Aaron instead whenever we refer to name. So we're going to combine the first two concepts that we just learned. We're going to dive deeper into variables when we get to go, and like the different stages of a variable. And actually we're about to look at some documentation. But if I were to run this, or to hit the play button up here, you can see here how it prints out Aaron. Even though we told it to print name, it prints Aaron. And again, it's important to note that this variable can hold a value, and that value is the true as the thing that you're going to be using with it. So and to show that it can change is that my name is Aaron first. I can now say name equals Sharon. and it's the same exact program, and I'll print name again. So take a look at that for a second. We're setting up a variable called name. We're setting it equal to Aaron. We printed it out. Then we're taking name again, and now we're setting it equal to Sharon. And let's see what happens after we set it equal to Sharon. I hit play. It prints out Aaron, and then it prints out Sharon. And again, it can do that because it is a variable. It can change. It is something that can be modified. It's something that can be changed. The reason why this thing is great is because now you have a way throughout your program to track a value. So you can set up a little box, a placeholder. You set up a variable, a placeholder for a value. And let's say it's something like a scoreboard. Maybe you're writing a scoreboard application for football or something. And as the score goes up, you can track a team score by one variable. So, team one score can start at 0. And as things happen throughout the program, it can be updated. And every time you need to reference that score, you just say, hey, what's team one score? And it'll print it out. And you can say, all right, they just scored a touchdown. Let's go ahead and add 6 to team one score. And it'll add it to, it'll add 6 to that value. So we can keep referencing that thing throughout our program. So it makes it a lot cleaner. It makes it a lot easier to do. But what we did here is we did this line will make more sense when we do it in Go, but we not only did we declare a variable, so variables have a few different parts. You can declare a variable, which is saying, hey, I want to use in this program, I want a placeholder for a value. I may not have that value yet, but I want to store that value somewhere. So I'm going to show you what that looks like in Go. And then what we did is we did a variable assignment. So we assigned a value to that variable. So we did it in one line. We said, hey, create name, also assign the value of Aaron. And Go, we'll do it in 2 separate steps. And actually, maybe we can do it in Python real quick, or learn why we can't do it in Python. Python declare variable. All right, so, and this is when you get into the differences in languages. This is some of the exploration that you should do, and this is the kind of exploration that only comes out of learning, really having something to compare these things to. So you see how to create a variable in Python. When you see how we create it in Go, or the ways that we can create it in Go, you can start to formulate questions of like, hey, why is this thing like this? Why can't I do this over here? But it says there's no need to declare a variable in Python. So again, declaring a variable, saying, hey program, I have a variable that I want to use later. It does not have a value, but I have it, and I want you to save some space in the memory for it. And then you can give it a value later. Python, you do them all in one line. Because if we're talking about variables and functions and modules, no declaration needed. Just assign a value to the name where you need it. So my magic equals magic. So that is what we just did. We can do it all in one line. Now, let's see how we do variables in Go. Let's do this for Go. Variables.go. Let's do it here. So why didn't it give me my stuff? I'm just put this is just the that skeleton code that we were talking about before. Do we need print? We need import FMT. I'll tell you when I get to the part that's not the skeleton code. How come it's not? Do I have Go installed over here? Hold on. It should be filling all this stuff in for me. Okay, that's why. Let me just get the Go extension so it gives me all the fanciness. Install all these pop-ups when you install a new plugin. Okay, so this is the skeleton code for this. The thing that we need to do now, so all of our code that we're going to write is going to be in here. The first step, declaring a variable. The way that you can declare a variable in Go is var name, but I actually have to tell it, because it's statically typed, because types are a thing here. I have to tell it what type to save for name. So name in Python, I can just put it here, and actually you can actually see if I do this, like if I change it to a different data type, actually I don't know what happened here in Python. It does work. So it prints out 5 and then it prints out Sharon. This is not something that you can do easily or in the same way in a statically typed language. So that very important concept, we're looping back to the interpreted versus statically typed, interpreted versus compiled, statically typed versus dynamically typed. This will infer your type. It'll try to figure out what type this is and do its best to work with it. In Go, that's not necessarily the case. Last class year parentheses on import. We'll talk about that in a second. The import line. Again, don't worry about syntax yet, but we'll talk about those parentheses on the import line in a second. But what we just did here is we have to tell it what type it is. So I do var name string. And so now I'm declaring a variable. So name will now be usable by my application. It's a variable that I can now use, but it does not have a value. So watch what happens if I do, I'll try to print it out. So we learn how to print. So I'll do format.println name. We'll try to print that out in a second. Why isn't this, that should run. What am I missing? Package, it's the main package. Let me look at, am I tripping? This is weird. So usually, so you talk about the parentheses. So if you only have one format package, you should be able to do it without it. I mean, it's fine, but did they change? They must have changed this in a recent version of Go. You used to be able to, no, see, yeah, this is a problem. This is main, what am I missing? Package main. This may not be a problem. It might just be being weird for me. Main redeclared in this block, previous declarations at line 8. Well, we'll see what this is in a second. Variables instead of it. Oh, why you're talking about the file name? Why does it say variable and variables? What do you mean? Oh, so these are the files that I have open. Sorry. So up top, these are just files that I have open. So this is the variable.py, and this is, I just called them, I don't know why I called them variables. That's why. Oh yeah, because I didn't sign a name. Yeah. That's that makes sense. So this line is declaring a variable, but this variable doesn't have an actual value. So in some languages, you can do that, and when you declare that variable, it'll get something called it'll get the 0 value. We'll talk about 0 values later on in this course. But I thought Go did that as well. But if not, we can also give it a name. So on a separate line, now we can do what we did before. So name equals Aaron. So yeah, I think this is what is, hold on, we can, what's the problem here? Previous declared, but not, this is really weird. I'm gonna save it. I'm gonna try to run this really quick because, variables.go. Okay, so it does work. Yeah, I think that was I don't know why it's showing this. I don't think it's a problem. This is not a problem even though it's doing this. So okay, so we declared a variable and then we had to assign it a value. So those are two things that happen. And there's also another step called instantiating that variable. But yes, this is which assigning it in some languages you can call it that. But right here we're setting up the space for the variable to be used. And then down here we're giving it a value, and then you can see when I printed it did in fact print. I know a lot of stuff here, but it did in fact print my name, which is Aaron. In Go, you can do it in a bunch, and you can do it in a couple other ways. There's actually 3 ways to declare variables. One of the other ways I can do it in the main common way that you're going to do it is Go does again have some of that type inferencing, so you can shorthand it by doing this. You can do this little walrus operator. People call it that because it's looks like a little walrus with eyes and the tusks. But you can do name := Aaron, and then you can print it out. So this is just like the Python one that we ran. We set up a variable. So we both declared it and we assigned a value to it in one line. So we told the program, hey, here's a variable called name that we want to use, and we're also going to give it the value of Aaron, and we'll try to print it out. it goes ahead and it prints out Aaron. So remember, with variables, two steps really happen, even though in Python you're only going to do it one way, but two things are actually happening. You're setting up a space for this variable to use. You're telling the computer, hey, I want to use this variable, but by default at first it doesn't have anything in it, and then you assign it a value, and a lot of times you can do that in one line like we just did here. So declare it, assign it a value, and then again that thing can change. So later on down here I can actually do name equals Sharon, the same way we did it before, and then we can print it again. And let's see what happens here. And I want you to, after we see what happens here, I want you to tell me what you notice that's different. So we're gonna run it, it prints out Aaron, then we change that variable because variables can change, and then it says Sharon. But what is different about what I did here and what I did here? And this is why we'll look at it for a second, figure out what the difference is, and this is going to be the reason why it's important to understand declaration, understanding variable declaration, declaring a variable versus assigning it a value. And correct, no colon. So let's actually see what happens if we add another colon. So up here, we did the same thing in both places, and it's already giving us a variable error, but we'll run it and see what happens. What happened? Oh, whoops! I actually deleted that whole line. Save this. Let's run this. So it actually fails. It gives us an error. It says no new variables on the left side of this walrus, and so what happens here is because this is there's so many rules for these statically typed languages, I've already declared a variable. So again, when you declare a variable, you're telling the program, hey, carve out some space for me to be able to put a value into later. And then I'm assigning it a value over here. When I try to do it again here, the computer says, I'm saying, hey, go ahead and carve me out some more space. And it's saying, hey, I can't carve you out some more space because you already have space carved out for a variable called name. I can't declare another variable for you. And so that's why it's important to understand the differences between creating a variable to be used versus giving it a value. They are two different things. So I have to just not create it. I have to just assign it a value. So whenever you see a single equals, that is called assignment across the board. It is when you see this, it'll say whatever's on the left, give it the value that's on the right, no matter what. It says, hey, whatever's over here on the left, give it the value that's on the right. It is an assignment operator. It's assigning this the value of this. And so this will allow us to have the same functionality that we had in the previous example, as long as you don't do that. So this is why these concepts right here are why I encourage people to learn a statically typed language, because again, this is something that may not it wouldn't present itself to you in Python, and there are a number of places where you can get tripped up as you're going through your career without understanding that those are two different things. Okay, so now we've done two things. We're displaying output. We learned how to do that, and we learned how to we learned about what variables are. Take a break for a second. I know there's tons of questions. Ask any more questions you need to ask now. Maybe we'll go through some more examples of this, but we'll move on to getting input, and then we'll mess around with that for a little bit, and then we'll move on to get. All right, what do you use Go for? Go is a systems language. Again, it's made by Google. It was created to solve some of their problems of they're a company that works at a massive scale, so they have tons of infrastructure, and so it's a fast language, and it's a relatively it's a pretty readable language and kind of easy to write language for developers. It may not seem like that now because we're comparing it to Python, but compared to some other compiled languages like Java or like C, it's a lot easier, a lot clean. It feels a lot cleaner to write. So it's used for systems things. It's used for tools. A lot of tools that you've used are built in Go. Docker. A lot of DevOps tooling is built in Go, but a lot of tools are built in Go, and it's kind of written for systems to be fast and performant, but it's also kind of general purpose. You can use it for scripting. You can use it for, there are web frameworks for it as well if you want to build web applications with it. It's used very heavily in the networking space. Python's used more, but Go is become pretty big in the networking space as well. I use it for mostly I use it for mostly automation and building tools for mostly myself. But yeah, mine runs but with an error. Main redeclare this block previous declaration. Yeah, mine is getting this error too. I'm not sure why. Like this, it shouldn't be like this. Is fine. This is exactly how it's supposed to be. You even see it here. I wonder if it'll give this an error. Oh. Sorry, I know exactly why it's doing this. The reason it is doing this, and this is another reason why compiled languages are they're very strict. The reason why is because up here we declare something called package main. For a Go program to run, it has to have this package main. You can have other packages, but it has to have this package main. The problem is in this same directory, we have other files that have a package main in it. So if we actually comment out this whole file, this error it'll go away. And you can see how like that's, you know, it even other files can affect how this operates. But that's why I was given the error. Is because you can't have two things in the same thing. Yes, importing the packaging and imports should remind you of Java. Tell us about global variables as well while you're at it. Perfect. No. We're not gonna talk about scoping right now. Scoping is a different animal. Just again, what you need to understand right now is that this is a value. It's a placeholder value, and you can assign it a value that represents it, and you can change that value while you're going through things. Let's see, where's my Vim? So you know, we're gonna ease into Vim. We're gonna ease into the command line stuff for everyone's sake. We're gonna ease into the command line stuff. Let's see, that's what I'm thinking of learning. I really may want to create tools for myself as well. Yeah, now Go is really good for that. And again, I actually really encourage for anyone who's looking to really get who's starting their journey and really wants to get really good at programming, not just coding for a job. Like, yes, I understand we're all trying to get jobs in this, but if you're really trying to become a good programmer in the future, I really do encourage you learn. You don't have to learn Go, but I really do encourage you take up a statically typed compiled language. And again, because of the rules, it'll help you start to understand why things have to be done, and it actually will provide you a little more. You actually have more available to you. Again, it's more concepts that you have to learn, but you actually have there's a ton of features that Go has, or all statically typed languages that that you don't quite have in those dynamic languages, and you can do things in different ways, and you can really think about efficiency a little better. But yeah, it's higher learning curve for sure, but teaches you a lot of super important programming concepts. When we use Python over Go, again, they're just tools for the job. So I think people are always looking for that exact right answer for when to use what programming language. They have their strengths and their weaknesses, but they're just like tools in a toolbox. There are times when you need a screwdriver. There are times when you need a hammer. But there's also times when, yeah, I need to get this nail in, but I could also use this other tool. I could use the side of some pliers to also hammer in a nail if need be. So they're all tools to get the job done. You can pretty much do everything with every modern programming language, but again, some just provide tools to make things a little bit easier. But again, Python's super. It's pretty easy to get into. Again, it's used heavily in machine learning and data science. It's also used heavily for scripting as well, web frameworks and stuff, building web applications again with Django. But yeah, Python is the most common dynamic language, but is Go the most common static? No, not at all. The most common static language is C. Everything uses C. Everything is built in C. Go is built in C. Everything's built in C basically. I don't know what the most popular compiled language is for work. It's probably Java still. Oh, it's probably Java, or I'm sure C# is up there. I'm pretty sure it's Java, but yeah, it's definitely not Go. Go is a relative newcomer. Java's been out forever. Go's been around for like 9 years or something. Like, it hasn't been around long at all. But it's grown heavily in popularity. I think it's I want to say last year it was the number one language that people were desiring, or that like people were desiring to learn, because it's pretty cool. What sort of automations have you built with Go? Tools to deploy things elsewhere? Yeah, so I built a lot of automation in AWS. I write a lot of lambdas, so a lot of serverless functions to do a number of tasks in Go. I've even done simple things like backup scripts locally with Go. I'll share some of it. I'll definitely share some of it. Is it good to know .NET, Python, and JS at the same time, or is it better to master one thing? So I recommend focusing your energy onto really learning one programming language, but to learn programming concepts, I highly recommend you take a look at two. .NET and Python are going to be fairly different in what they do in JS. Like, I don't think you need to focus on all three of those at the same time at all. I don't think they're all that complementary, to be honest. So I wouldn't. If you're going to go down the .NET road, .NET is its own kind of ecosystem, and so that'll take you down one direction. I think if you learn Python or JS, it's pretty easy to pick up the other one. So if you learn JavaScript, I think it's fairly easy to pick up Python and vice versa. But yeah, I would, if you're really trying to get good at a language, like when you're really trying to get to that point, like focus on one. But these concepts that we're kind of learning here, if you don't have the basic programming concepts first, I wouldn't focus on all of them. I would focus on two that are going to present you different information. Again, like one statically typed language, one dynamically typed language. I would recommend C#. Yeah, a lot of people recommend C#. I have my concerns about C#, even though I know C# is great. My concerns about C# are purely around the .NET ecosystem and getting pulled into the .NET ecosystem, not because it's bad, not because it's bad at all, but because I think getting in there early, I think when you're first getting into programming, I think C# is a great thing to learn the concepts, but falling into the .NET ecosystem that early and being not being exposed to a lot of the open source things can be detrimental to your career, to be 100% honest. A lot of people who I've seen who are coming out of the .NET the .NET frameworks, who've only lived in .NET frameworks, really have trouble in the rest of the world, of kind of open source technologies. But again, everyone's different. Okay, let's keep going. Now let's talk about input. So we learned how to get stuff out to the screen, and we learned how to we learned about variables and how to save this space on the computer so that we can provide a value, that we can have a space to represent that value. Now let's learn about getting some input. So let's make a new file, call it input.py. Let's go back to our slides. What's up, Pub Wasabi? Welcome to the channel. Thank you for the follow. What's up, Pia Murphy, Batty Han, Fish Kung Fu, Heisenberg? What's up, Y Guys, Mellow Man? Welcome. What's that? Awesa Mondi. I need to make this bigger. Lurk Ops. What's up, everyone? Welcome to the channel. Good to have you. All right. So next, we're gonna do user input. So these are kind of the core base things you need to kind of start playing around with the language. Again, display output. Variables are very important to kind of save some values, and then getting user input. So sometimes you'll want to get information from the user. You might want to ask a question. Before we were setting up our name equals Aaron, what if we wanted to ask the user what their name was, and maybe we want to save it that way? And the way that you capture user input is you ask for it, and then when you ask for it, you capture it. And so how do you capture it? You capture it using a variable. Remember, a variable is there to hold a value, to hold some data, inside of it. Remember that box. And so you ask for it. So in Python, we're going to use this. There's an input function to do that. And so we're going to put an input. We're going to type to the user what we want them to input. And then when they do input it, it's going to give them the ability to enter it on the command line. They can enter it. And then it's going to save it to, we need to save it to a a variable to keep it. And if we don't save it to a variable, we don't keep it. It kind of just comes into the program and just it doesn't get captured. It's just, you know, it's kind of useless. So you can do input without capturing it, but you're usually going to want to save that input. So let's do it in Python before we do it in Go. It's much more difficult in Go, and it's really going to confuse you, but again, the concepts and the differences are pretty important. So here we just say input, and then we ask what we tell the user what we want them to input. So please enter your age. All right, and then I'll do a little colon there because people are used to seeing these colons as like a prompt, and I'll put a little space here to give someone a little bit of space. And so I'm actually going to save this. I'm actually going to run this as is. So input is the way that you do it, and actually if you have everything installed, you can put your mouse over input and it'll tell you, it says reads a string from standard input. We know what strings are. Standard input is going to be this this place in the console, which is also standard output. And it gives you some more information about it, but ignore that for now. If I hit play, it says please enter your age, and it gives me a space to enter my age, and I'll say 30. And hit enter, and then it's done. Nothing happens. We got no errors. That's because this program successfully ran. We passed our input in, but we didn't do anything with it. We did nothing with it. A program is only going to do what you tell it to do. So what we can do is, if we want to confirm that we input something properly, let's set the value of this to a variable. And the way we do that is with assignment. Remember, assignment is with that equal sign. So let's make a variable called age. And as long as we put an equal sign here, it's going to make this value, it's going to set it equal to whatever is over here. So it'll ask for input, and whatever we input will get set to the variable age. And then, so we can run this again, but when we run it again, what's gonna happen? It's gonna do the same thing. And why is it gonna do the same thing? Although we set it to the value of age, we haven't done, again, anything with age. Like, we still haven't done anything with that output. So just to confirm that everything's being caught, let's see if we can print what we got. So now we're gonna print age. So first, it's gonna run this line, and it's going to take in your age and set it equal to the variable age. And then we're going to try to print out the value of that variable. Let's save this. Oh, it's already auto saving. And when I hit play, I'll put 29, and you can see here, it takes it in and actually prints out 29. So we are taking that in. Yeah, we're actually taking that data in. So we're just capturing that input. The input function does a bunch of stuff in the background, and it's what allows for that stuff to be input on the terminal. So you can try that yourself. Simply put input. So this set of text can be anything you want. I can run this like this. It just won't give me any text. That's so annoying. I run it again. Oops. That was right. I run it again. It looks like it's stuck, but we didn't tell it to say anything. So if I type in 20, it will print back out 20 because it is waiting for input. So input is the way that you can take an input from Python and say what is your age, question mark. Okay, and that's how we do it there. Pretty simple, right? It's like, all right, you know, it takes a while to learn you know, all the different things you can do, but the task itself is fairly simple. The word input, we understand what the word input means. So, you know, it's not a wild, crazy computer word. It's using nice plain English for us. We know we can put some words inside of here. We set that input to a value, and then we can do whatever we want with that value. Here, we're printing out that value. In Go, the process is much more difficult. So any questions about that before we get to Go? Down your interest. I like the conversation about which programming language to choose. I can't tell you how valuable I would start copying down people's responses. Like, I think Civil's response, perfect. Like, copy and paste that into your notes somewhere. Start to write these things down that people are kind of discussing. These are the conversations that get you jobs. These are like learning how to have these discussions and learning how to just talk about the tech is what gets you the job. You can win over anybody. You can win over the interview by just being knowledgeable about some of these things and saying, hey, I don't like, if someone might ask you like, hey, what programming languages do you like, or do you want to learn, or why is this better than that? Maybe there's an answer, maybe there's not an answer. Civil says, hey, it's completely down to your interest with which one you want to learn. That's 100% true. But these are great conversations to have, so I'll copy them down. I really would. Like, all of this information is super good. Java is Java's for a lot of things. You can definitely build games in Java. Java is used in tons of enterprise applications. I think Android, I think you can write all your Android stuff in Java. So a lot of Android games are written in Java and stuff, but you can do pretty much anything in Java, to be honest. I don't really like Java. Why doesn't it ask me to enter my age? It all depends. If it didn't ask you, it's because you didn't put the words that in here. Make sure you put the quotes. It needs to be a string. Let's see. How do you do it so they have to enter a number? Great question. We're going to talk about data types next time, but and so you can enter a number. So this will allow me to enter whatever I want. If you want to make sure that it's a number, there's a number of ways to do error checking. We're going to learn error checking later, but throughout the algorithms, we're going to learn how to do that. That's a come back like next week, maybe the week after. We'll start to talk about how to do that. There's some checking that you can do when someone inputs something. Some checking that you can do to determine whether or not it's a number or a letter or whatever you want it to be. And so we can once we start learning how to incorporate some logic in our code, we'll get there. We'll definitely get there. All right, here we go. So in Go, it is so, whoops, let's put this, I didn't mean to put that over there. In Go, it is substantially different. What is this? Sorry, I moved it and then all of my stuff changed over here. What is not important? Okay, Go is completely different. Now this is going to confuse you, but it's going to allow us to talk through some more of these concepts. Yeah, it's gonna be a doozy. All right, so let's do an input.go. And so a language like Go is going to speak a little more to the things that we are learning in the computer sciencey parts of this. Bits and bytes and binary is more relevant in a language like Go than it is in a language like Python. Again, you're a little closer to the system in something like Go. So why didn't it give me, okay, we'll do another package main. We will import, yeah, I definitely don't need from, well, I'm actually going to be using a number of packages in this, so we'll set this up properly. And func main. All right, so Go actually requires so Go this import statement here. Go has a number of things in what's called the standard library, so it actually has a number of tools available for you to use to do some cool stuff that you want to do. But for efficiency's sake, make sure you import certain things when you need them. It doesn't give it to you out of the box. You've got to import them. So there's actually a couple packages that we're going to need to be able to do this. There's one to be able to handle buffers. So getting input from Go is and actually Python does a lot of this stuff before you. We're going to need to basically read in. We're going to basically do some magic and read it. We're going to be reading in the bytes, a byte stream from the standard input. So when we're typing things in on the line, we're actually gonna be kind of reading in those bytes. We're going to be kind of taking a look at those and inspecting them, and then we're actually going to be setting a variable equal to those things. There's a lot of pieces. We're going to be looking for errors and things as well. There's a bunch of crap that we have to check for throughout this process. So it is yeah, it's kind of annoying to do. So let's just start it out. The first thing we have to do is we actually have to set up something called a buffer. We can call this whatever we want. So we're setting up a variable. All we're doing, we're setting up a variable. The one that I'm going to be using to highlight this is called buff, just because this is a buffer. And what is it? Actually, I think I need to import to the buff. Was it buff.io or is it buff.io? Let me pull up the, no, I'm pretty sure it's buff.io. So I'm gonna do this. Trying to remember how to do it. Import, I need a comma here. Import buff.io. So this buffer is gonna allow us to, it has some methods on it that's gonna allow us to read in things that are going to happen on the command line. So I think it's buff.io dot new reader. Yeah, so I actually have to read it. I have to actually stream in the things that are coming in from the command line. And so what am I reading? So this buff.io dot new reader, I can actually read in things like files and things like that. No big deal. But what we're gonna actually do is actually think I have to import another package, which is the OS package, and you can already see how this is a lot right here. And the goal is not for you to learn this. I'm not writing this for you to learn this. You don't even need to type this out. I'm gonna type it out for you. I can paste it for you to copy and paste if you want. You do not need to know how to take input and go. There's just a number of concepts in here that are going to be super important. But I want to take in standard input. So we talked about standard in and standard out. This is just the place that the computer outputs data and receives data into it. And so we're going to read from standard in. And so this is going to set up a buffer for us, and it's going to kind of leave that open. And we need to go ahead and tell the user what to do. So we're going to say format dot print line, what is your age? And I don't even know, this might suck because I might not even be able to put in a I'm not sure I can put in a number by default. And then so now we're gonna need to capture that. So in programming languages, we're gonna get there a little bit later. Functions can sometimes give you back different amounts of data. A lot of the things in Go actually give you 2 pieces of data. So I can set up a variable called age because we care about what age is. But it's also going to take something called an error, it's possible for it to return an error. So if we do something wrong, an error can actually be returned instead of the data. And so we actually need to capture that here. And this is actually, these are variables as well. So age is a variable, but also so is error, but we can set those up on a single line with this comma. And so again, it's a little bit interesting. These are also not something you should know. Just trying to walk you through what I'm doing while I'm doing it, so that you can start to understand what, see the differences, not understand what we're doing, but see the differences. So there's already a lot here. We're reading from standard output. We're asking what the age is. And then we're actually reading from this reader. So I called buff up here. I'm actually reading the bytes from buffer here. So I'm actually reading those bits and bytes. I'm reading that binary to determine what the characters and things are that are coming in to what we have here. I could leave it like this, but I also need to give it a delimiter. So I want it to do new lines. I want to do new lines here. And then the problem is I could do something like format.println. I could do format.println age. So it's a bunch of stuff here, a bunch of crap. And look how much bigger it already is than the Python app. Pretty simple Python app over here. The Go app is already crazy. This is actually not going to work. I'm going to run this. This isn't going to work. And we're going to see why it doesn't work. Go run input.go. It doesn't work. Can I use new line? I didn't expect that one. Let's type byte an argument to buff read bytes. untyped string. That's interesting. Okay. Sorry, it can't be a string. This needs to be a rune. Hold on. How do you do? Yeah, there we go. What? There we go. There we go. So this should break as well for a different reason. And then it says error was declared but not used. So the error is a variable. Again, this part is very relevant to what we normally do in a statically typed language. You cannot declare a variable. So remember, declaring versus assigning it a value. You can't say, hey, give me space for this thing, and then not use it later. Like if you declare space for it, if you set it up, you have to use it later, or a compiled language will break. It'll tell you, hey, you can't do that. You need to clean this up. So we declared it, but we didn't use it. And so I've seen people try to do stuff like this, where they just use it, which is not, I actually don't know if this should break as well. But I've seen people try to do this a number of times, and it does. So this seems like it's going to work. I'll put in like 34 or something, and then some stuff happens. But generally, this is kind of the wrong way to do it. You need to do some error checking if you want. So you can do like if error is not equal to. See, this is a lot of stuff, but I'm representing this to you right now to show you. I really want you to understand the depths of the rules and the interaction that languages like this have. And I want you to know, I want you to see this early on, so that as we're going through things, you can start to formulate some of those questions, and you can start to be like, ooh, okay, well, I learned this thing in Python. I'm going to learn Python right now. I'm learning this thing in Python. Maybe I'm wondering how, maybe you need to be wondering about how it works underneath, maybe, or like or like what programming concepts are truly happening throughout that process. Again, this is not just a coding course. This is a computer science course. So we want to understand what we're doing and why we're doing it, and kind of what all those pieces are, rather than just trying to get tasks done. So yeah, so you're gonna be learning both at the same time. So it's overwhelming, but I'm gonna be showing you a lot of this stuff here. So if there's no error, I can go ahead and print out the age. Or if not, I can go ahead and print out the error. And I'm gonna walk you through some of the logic of this actually as well. What time is it? Perfect. All right, so instead of doing what we did down here, I'll remove this. This is a common paradigm because it's going to give us either age or an error. It's going to say, hey, if there's an error, if there's not an error, go ahead and do this thing. But if there is an error, just go ahead and print out the error for us. So let's see how this program runs. My age is, I'm not 34. But it didn't print it. It printed out nil. And so it probably printed out nil because it's not a string, or is it a string? Let's see. Let's try. Okay, it's giving us nil, and it's printing out the error of nil. Interesting. What are we doing wrong? Age, buff, read bytes. We might not need this delimiter here. Let me just see something. I just want to get the right output, but this is very close to what it's supposed to be. But yeah, it's got to be the rune of new line. But it doesn't fail. It's gonna print us out this stuff. Nil. Do I have to? If error is not equal to nil, oh, but age is coming through as nil, which is interesting. Not a big deal, but this is basically what it is. We're really close to it. I don't want to hold up too much time, but look how much more things there are. We're doing some things with assigning variables, but we're using all this extra stuff. We're printing stuff out. We're setting up two variables, or possibly two variables all at once. And again, this is foreshadowing. This is all foreshadowing to the things that we're going to be learning. A lot of extra stuff. That's why we're working on two languages at once. So this probably feels good to you. And hopefully, even just looking at this, makes this seem so much better. But so the goal here is that you can consume input, you can take input from the user, and you need to capture that input. You need to save it to a variable. That's one of the things that variables are for. If you set up that space for something to be used, you can store data into it. So use that stored out space to save data to, and you can do that using the equal sign. So the equal sign says assign whatever's on the left the value of whatever is on the right. So lots of wild stuff, lots and lots of wild stuff so far, but foreshadowing, showing you how crazy programming can get. And really, once you kind of start to pick things up, it's not that crazy. But I just want to show you the levels of it. I can't tell you how many times I've seen people dive into JavaScript or dive into Python and try to go do something else and work on a project to where now they've got to work with Java or they've got to work with C# or something, and really break down when seeing what is the perceived complexity of a compiled static language. So throwing it all to you up front, I want you to get uncomfortable right now so that you'll be more comfortable as we slowly go through it. You don't need to know this. I'm gonna paste this code in if people want to mess around with this. Actually, we're gonna put it in GitHub in a second. But wild stark differences. How are you all feeling about the stark differences? People who are new specifically, like, does this look as wild as I think it looks to you? I should go over everything you just did, please. Yeah, I can't go over that, but I want people to type out their answers for that. Wilder, even wilder. Perfect, excellent. It should. So yeah, I'll tell you everything I just did. All I did here was I imported some packages again. So Go has some extra tools for you to use. So these tools that we're talking about, when you're typing in input right here in Python, so this is the Python code. When you type in this input, this is a tool that Python gives to you. It actually does a bunch of other stuff. There's a bunch of code written in the Python library that supports what input does. It is, all that stuff is written. Basically in Go, Go is a language that they kind of don't believe, they don't want to give you all the magic. They kind of believe they just give you the necessary tools and you got to implement it yourself. We are basically doing all the things that are necessary to set up something like this input. So what we did here is we imported some packages that allowed us to do some things. So this one was buff.io, is allowing us to create a buffer out of input and output. So I'm gonna show you where to find this information. It'll take you forever to learn that this is a thing. A lot of it will just come from Googling, but this is a part of their library. But it basically says, hey, go ahead and create a buffer out of the input and output of the machine. And so what we did is we used that package. It has some tools in here called new reader, which will allow you to return a new reader whose buffer has the default size. Great. Doesn't make any sense. But all we did was with this line is say, hey, get some information from standard input, which is the command line, and assign it to the variable buf. So buff is a variable, and I assigned what's over here to what's over here. Then here I printed out to the user, what is your age? I asked the user, what is your age? We saw how to print out output. That is why when we run it, it asks you, what is your age? It prints this out to the command line. The next thing it does is it's using some more tools to be able to return two items. So one is age and one is error. So here, this line is the same thing that you've seen before. It's the same as this line. It is declaring variables and assigning them values. This read bytes thing, it actually returns two things. It actually returns two values. It returns a byte and an error. So we have to catch both of those things. So age actually has a value and error actually has a value. And then down here, I'm just doing some checking. I'm saying, hey, if we got an error, I want you to, well, if we did not get an error, go ahead and print out the age that was passed in. But if we did get an error, go ahead and print out whatever that error is. And again, a lot of concepts there, but I'm glad it's wilder. It is a lot. It is not something you should understand. Even I would say it's not even something that you should understand even close to the end of this beginner course. I don't even think you should understand everything that's going on here at all. But again, this is to show that this is to contrast the stark differences between the two, and to immediately show you the depths of where this stuff can go. Let me show you guys one thing real quick before we move on to the next part. This right here is the Dunning-Kruger effect, and what we're doing is we are shifting this. So the Dunning-Kruger effect is something that heavily affects a lot of people. It contributes to imposter syndrome, and so you're probably having some imposter syndrome right now. But the Dunning-Kruger effect is a paradigm that happens when you start to learn something new. So take a look at this line on the left. This is your confidence. This is your level of confidence when learning something new. This line down here is how competent you are actually at that thing. So when you're learning something new, you start and your confidence shoots way up. So if I started to teach you Python and you were able to do output, and you were able to do create these variables and do a lot of stuff really fast, you're like, oh, this is pretty easy. I'm really getting this. Everything's super great. And your confidence shoots way up. And then you start to understand the depths of what you don't know. So as you start to dive deeper into it, you start to realize there's so much more underneath that you don't know. So the problem is you're getting better and you should be confident, but your confidence drops sharply. And this is where imposter syndrome happens. This is where people quit down here. This is where people quit. And then, as time goes on, you start to get more and more competent, and you start to learn more, and your confidence starts to go back up. All right. What we're doing right now is we are shifting this. We're making sure you don't get all. We're making sure you don't get all the way up here. We're only letting you get to here, so that we can immediately drop you back down, and that the curve will go a little more like this, and it'll follow a different trajectory. So that you're being immediately introduced to the stuff that you don't know. And it probably dropped you down a couple notches. It probably, as you started to feel more confident, it probably brought you down a little bit. I'm sorry about that. Had to happen at some time. But what it's going to allow us to do is to more easily change that trajectory to where we can feel more confident at other levels. So that's why I'm introducing this stuff to you now. So you can feel a little bit better about that. But you should check out the Dunning-Kruger effect. Read up a little bit about imposter syndrome. This stuff's real. I can guarantee you're all going to go through this at some level, and we're trying to mitigate the drop here. This is the scary part. This is the only scary part, the descent into chaos and then moving back up. So let's get in there. All right. Okay, now let's that's the coding for tonight. That is the coding. I encourage you to mess around and print out new things. I'll paste the code. We're gonna push this code up to GitHub. You're about to learn about GitHub and learn about Git, but start to look up the things. Like try like looking at this and saying, all right, I got no idea what's happening here. What I did understand is that I know when I see a little walrus thingy that I'm setting a variable. So that must mean this is a variable. I have no idea what any of this means. None of it. Maybe you can start to Google it. And maybe you can just start to look through the documentation. It won't make any sense, but you will pick up some things. You're like, all right, man, or you can just highlight it like this. You can say, all right, a new reader returns a new reader returns a new reader whose buffer has the default size. Makes no sense without any context. It makes no sense with context, honestly. But now you're starting to see words, you're starting to see phrases, you're starting to see symbols, and you're starting to see structure even in this box that is valuable, that'll start to make more sense as you start to learn more things about functions and what this is actually telling you. This red star that is up here near reader means something, and again, right now it'll mean nothing to you, but you'll start to pick that up and you'll be like, oh, okay, one day you'll learn what that star means, and you're like, oh, I've been looking at that all this time. Now this stuff, you know, now I have some context to this block here. But yeah, explore it a little bit, play with it a little bit. It doesn't really work right now. We'll look at this before this is over. When we push it up to GitHub, we'll check it out. But yes, explore, get comfortable. That's all the programming concepts tonight. So the programming concepts are displaying output. How do we display output? We send data to standard out via some type of print or write function, but print, you just print it out. So in Python, it's that print command, and Go is format.println. So that's dope. You can just print stuff out. And there may be a number of ways for you to do that in a language. We know that we can get input, so we can output stuff. We can also get input from the users as well. It's done differently in different languages, and Python is just the input function, and we can use that. But we know now that in programming, we can get input. So when we go to solve algorithmic problems or any problems, knowing that you can get input is important. Knowing what you're capable of doing with the programming language is very important. Now you know that you can get input from a user from the command line in these programming languages. You also now know what a variable is. Hopefully, maybe you don't fully understand it yet, but you've seen variables now, and you know that there's a paradigm in which I can set up a space to save some value to, and that value can change because the word is variable. It can switch up, it can be modified, it can change over time. There are things that don't change, and that's why it's important to know that variables do change. We'll talk about things like constants later that do not, but variables can change. And again, the little box, go back to the image, the little box that holds the value. That's what you need to know tonight. Those are the programming concepts you need to take away from tonight. Anything else you get out of the syntax of what we've done, anything else you get out of trying to run it and what you learn from trying to install these things is a plus, is all good. What's up to Dev08? How you doing? Thanks for the bits, always coming in hot. I love it. Okay, so now we've made solid time. There will now be a pretty clear distinction between what we've just learned and when we get to Git. We're about to learn about version control in Git. I think the good thing is that the cognitive load shift will make it easier as we're going through. So if you're feeling fatigued, I actually think it'll help because the concepts of it are a lot different. Well, I feel are a lot different. Maybe I'm completely wrong about this, but we're about to learn about Git, the technology. We're about to learn about source control and version control. We're about to learn how you manage code. So the high level things which you should focus on. Today we've learned that you can output data, that you can grab input. We've learned that you can store data in variables that can change. And now we're about to learn how you manage your code and how different people work on the same code at the same time. All right, so we only got about 30 minutes left, so we're gonna run through this. Yeah, anyone have any questions? Learn how to plug your questions in a search engine probably. Yes. So man, I actually think one of the single biggest best things you can do, and I encourage you to start Googling now, because through Googling through Googling your questions, you'll start to see patterns and you'll start to learn how to search for answers. You can't always just search. Well, like part of the learning process is learning how to search for these answers and learning what you can plug into Google to get back the things that you need and the things that you want. And the way that you start to learn that is by trying to do it and seeing what you get back. And as you make modifications and adjust, you'll see different things come back, and you'll start to see how the answers are formatted as well. And you'll start to understand how coding answers are formatted and the things that you need and things that you don't need. So yeah, so start Googling things right now, but it helps you to Google those things when you know what you're trying to do, when you understand the concept, when you understand that, hey, I'm trying to get something, I'm trying to output information, I'm trying to Git user input. Like knowing that's what you need to do helps a lot. What situations is Go ideal for? Anything that you want to do that you want to be fast and that you want to be performant. Yeah, I mean, again, the use case for the language, it's a systems language, so generally you're going to be using it for systems, processes, and things. But again, it's a fast language, pretty easy to write in comparison to a lot of other lower level languages like C. Yes, Go, the name makes quick Googling a nightmare. That's why if you're looking for answers with Go, you should type in Golang, Go L-A-N-G. But the language is called Go. It's not called Golang, but Golang will allow you to search for answers a little more easy. Okay, here we go. Let's go into Git. And this is gonna be a lot more fun for a lot of people, to be honest. You're gonna get a little more instant feedback from this, and it's gonna be a little less confusing. But again, the whole goal of this is learning how to program. And so we're gonna be learning how to program throughout the entire thing. So every single thing that we've done tonight, we will do every single, these are the building blocks. We will do this every single class. So every single class we're working on something, we will display output, we will create variables. We may not get user input, but a lot of the times we will. So this is not gonna be the last time you do it. We're not moving on from this. These are building blocks that we will continue to practice every single time we touch this stuff. So let's get on to Git and more so version control. Not necessarily, we're learning how to use Git, the tool, but we're learning about version control as well, the understanding of what we're doing. So what is version control? This is also called source control as well. They are different paradigms, but done in the same way. But version control systems are a category of software tools that help a software team manage changes to source code over time. What does that mean? That means that just like your files in Microsoft Office or in Google Docs or whatever, you can follow changes to those things, and I'll show you that in a second. But this version controls are tools that help teams understand the changes and track the changes that happen through code over time. That's very important. So just like right here, all changes saved in Drive, you can see the changes that were made here. So like, look at these other versions of this thing, like changes that I made today. You can go back and you can see some of those things. Or maybe you can't, I don't know, but like, that's what it is. So it's that same paradigm. It's the history of a file and how it got from one state to another state. It's very, very important in the software industry to be able to know what has happened in the history of these files. So again, it's a software system, it's a control system that allows you to easily manage and understand that. So version control software keeps track of every single modification to the code in a special kind of database. So all the changes that are made to a file, it keeps them in a special kind of database. If a mistake is made, developers can turn back the clock and compare earlier versions of the code to help them fix mistakes while minimizing disruptions to all the team members. So it's, we're humans. We make mistakes. If a mistake should happen, it's easier to remedy if you know what the last working state of that file was, and that you can go back to compare and figure out what happened, and then you can more easily identify the areas that were that caused the problems as well. So very important paradigm. So the way that we do that is with a software called Git, and Git is, I really believe, I only say, the only thing I say that is a bigger open source contribution to the technical world is Linux, but they were made by the same person. And the only reason I say Linux is a bigger contribution than Git is that it does more than just help you write software, and you can't run Git really without that underlying operating system or Linux. So but it was created by Linus Torvalds, the guy we said when we talked about Linux, created by the same guy. But what is it? Git is a distributed version control system for tracking changes in source code. we'll stop there for a second. Well, during software development. So distributed version control system. So let me actually see if I broke that down. I did break it down after, so I won't break it down now. I will read it first. Distributed version control system for tracking changes in source code during software development. It is designed for coordinating work among programmers, but it can be used to track changes in any set of files across the board. So you can actually use this. Our design teams have actually used this to track changes between design documentation. You don't get some of the granularity, but you can track versions of those files. Its goals include speed, so it's quick, data integrity, making sure that data is safe and reliable, and support for distributed non-linear workflows. Tons of buzzwords in there, lots of just stuff, a whole lot of just stuff. But what the heck does all that mean? What does distributed mean? The word distributed itself means things are in, they're not in a centralized place. They're in different locations. And so it means there's no central version of a code base. Each user has a full working copy and the full change history of that. So that means that there's no like file server that this thing is just sitting on. It means that there's no one source of truth. It means that everyone's computer or everyone who has access to this is the source of truth. Everyone's version of this is the version. The real thing is the combination of all of them. So each individual user has a working copy of the code and all of its changes that have ever happened. So very, very important. So it has a blockchain. It does not have a blockchain, but the concept of kind of this distributed computing and distributed processing is the same. Happening in different places is pretty important. Blockchain's a little bit different because blockchain, everyone has pieces, whereas opposed to this, where everyone has the full working copy and all of the history of the files. So it also means it tracks changes to a code base, and it exchanges patches when the code base needs to be synchronized. So what does that mean? That means I have a file. I have a simple file that says, hello, my name is Aaron inside of it. It means that this file needs to be changed, and someone else, one of you, changes that file and says, I actually wanted to say hi instead of hello. So now it says, hi, my name is Aaron in it. Your computer, Git will create something called a patch. So it'll say, hey, the last known working version of this thing, the last known version of this code I had said, hello, my name is Aaron. You've made an update to this code base. I'm going to make a file that tells this code base how to get from hello, my name is Aaron to hi, my name is Aaron. I'm going to put the stuff in there to show the differences between these two files. Then I'm going to distribute that patch to everyone else who needs it. Well, that'll probably come later, but that is how it happens. So then that patch will get distributed to other people, and it will make those changes in the code base on their computer as well, so that the code always can stay up to date. It's a pretty interesting thing that you can see in real time, that we're going to see in real time tonight. But yeah, it's distributed. It's on multiple people's computers. It's in multiple nodes. It's not all in one central place. Like if we were all editing a file in Google Docs, if we were editing the same file, we'd all be logging into Google Docs and editing that one central file. This would be like if we all had copies of that file, but we were able to come together, and when we made changes, Git would track those changes and make these little patch files to show everyone else, to tell everyone else's computer how to take this file from point A to point B that it needs to be at. All right, so that's Git, the technology. People get this confused with the GitHub. It's not GitHub, it's not all the other stuff. Git is its own technology. But Git has things called repositories. So what is a Git repository? A repository is a place for our code to live. So our code needs a home. Git repositories store metadata. That's just a little bit of information, a little bit of text data about information. About these files, for a set of files in our directories. It stores the set of files as well as the history of changes made to those files. So the first thing we said is that Git is a distributed version control system. Now, That's great. It does work distributed. It works, you know, like that. But it does help if that code does have a centralized place to live, where everyone can send their changes for other people to grab. Because you can imagine that if I did made some changes to the code and there were 20 other people working on the project, yes, I could exchange these patches with them to help them out. But you can see how that would all get, like, it would get a little confusing, and you got to share with everybody and you don't know who did what. So it needs a home. So a repository is just a holding ground for that. So in these repositories, it keeps the code, the files themselves, as long as metadata about those files and their state and the history that happened to them keeps them there. So it's also centralized, so it's one place. This is where GitHub and GitLab and all the other stuff comes in. These are Git repositories. These repositories are not Git. Git is different. They are all services that exist to support the service of Git, the tool of Git. So GitHub is the biggest. It was acquired by Microsoft for a ridiculous amount of money. It has the largest market share. It's the one that we're going to be using. It's the one that you should be familiar with. Even though they're all great, you should be familiar with GitHub. You should use GitHub. It has unlimited free public repositories, so you can have unlimited code bases in there, public ones, and you can also have unlimited private repositories, but only 3 people can be contributing to it at once. GitLab is another one. It's more than just source control management. That's what SCM stands for. It's more than just source control management or version control management, whatever you want to call it right now. It does a lot more than that. It has stuff for project planning. You don't need to know what CI/CD pipelines are, but it's a way for you to move code from where you write it on your computer onto a system easily and automatically. Monitoring metrics, so you can see what's going on. That also gives you unlimited public and private repos. It is a good service. It's just not nearly as big as GitHub. Bitbucket is another one. Atlassian products, it's from Atlassian. Atlassian is a company, I want to say they're Australian, that they just buy up a bunch of companies and repurpose them. But if you've ever used a project management tool called Jira, or Confluence is commonly used at a lot of companies, this is the same company, but Bitbucket is their tool that allows you to it's their Git repository that you can push code to. It's got some cool features as well. You should be familiar with the other services. You don't need to know how they work at all, but GitHub is the one that you need to be familiar with right now. And again, it's very, very important that Git is not GitHub or GitLab or Bitbucket. They're not the same thing. A lot of people confuse GitHub and Git. They're two separate things. Git is the technology. Git is the actual technology. And all of these are just services. They're repositories for your code. They're places for your code to go, to use. You're going to use Git to manage your code in these places, and they're interchangeable. Git works with all of them because they're all built on top of it, basically. So right now, I want you to go ahead and create an account on GitHub. So ! GitHub, I think we'll give it to you. If not, yeah. Well, that's my GitHub, but head over to github.com and create an account. You need one. It's super important. It's super easy to do. You simply go here, and your screen's gonna look different. It's gonna look like this. Simply just put in a username you care about, put in your email and a password, and get yourself a GitHub account. I'll give you a few minutes to get your own GitHub account. We have time, and then we'll learn how to use Git. We'll learn the basics of the Git technology. This is not the only session we're gonna have on Git. Git is very simple to understand upfront, to do the main thing that it does. It's actually a pretty simple concept. I'm basically going to give you 4 commands that you can do, and you'll be able to copy and paste them in that order. You can memorize the order, and you can do what you need to do on your own with Git. But that does not mean you know Git. Git is an animal. Git can be very complicated. Imagine there's a lot of tools and there's a lot of caveats. There's a lot of things that go on in Git. Imagine you have a huge software repository that thousands of developers are contributing to. You need to know how to use Git to untangle some of the conflicts. You need to use it to be able to manage your workflow. So I don't want you to, when we first start this, I don't want, like, you, again, the Dunning-Kruger effect. You might think you know Git. I thought I knew Git when I learned what I'm going to teach you tonight. I was like, oh, Git's easy, super easy, and I know it, but there's so much more to it. And I think if anybody was in any of the one of the panels, we had a guy here from the company I work at, Fearless. He's one of our engineering coaches, actually, and he said one of the questions he likes to ask in an interview is, on a scale of like 1 to 5, how well do you know Git? And it's actually pretty telling, because people who are pretty junior, who've used Git on their own to manage their projects, will say 5 or 4, and it's very telling. And it's not a deal breaker or anything, but this, like, anyone who's used Git extensively knows that you don't really know Git. Like, most people really don't know Git, and again, it's just, the more you've touched it, the more you find out the lengths that you can go, the different things you can do, and it can be pretty intense. So let's see, most of these tools have their respective tools to use with their services. Correct, Civil. A lot of those tools, things have changed since I wrote those slides. GitHub actually has a lot of things that that GitLab and stuff has. They all kind of have their own tools now. They're all kind of self-service, they're all full platforms now, to be honest. GitHub actually just came out with a really cool thing, and I actually think this is going to be a game changer, to be 100% honest. They're not the first to do this, but they came out with something called Code Spaces, and as soon as this is in general availability, we will be doing everything on this channel, because it'll make things easier. You won't have to know how to get these things installed locally, but you can still understand all the concepts. But it's like a virtual workspace that handles all this stuff. And again, the run times, everything, it's in beta right now. You can request early access, or it's in alpha, I guess. It's really cool. I'm telling you, as soon as this is released for general availability, this is absolutely what we're going to be using, because Microsoft owns GitHub. Visual Studio Code, which I told all of you to use, is written by Microsoft. They've incorporated basically an online Visual Studio Code in here, so everything will be right there and easy for you to use. Truly a game changer, and it'll make everything, not everything, it'll make learning how to code easier. There's still a lot of concepts outside of that's people are going to have to learn it. As someone who loves like DevOps, my problem with this is it's going to further separate. I think it's going to further separate software from the rest of the pipeline. Even though you can perform it here, people aren't going to know what's going on, and developers are going to be able to basically separate themselves more from what's happening underneath, which I think is going to cause problems in the future. But it's going to make it easier to learn. It's going to make it easier to do things quickly. It's going to make it easier for collaboration. It's going to be pretty dope. So I would request, once you get signed up, I would go to this page here and request access. I actually have access to it. I've messed with it a little bit. It's pretty cool on one of my other accounts. But yeah, request your early access here if you'd like. So I'm gonna sign back in to GitHub real quick. Actually, I don't think I requested it with this account. Oh yeah, I did, but I already have it on another one, so it's pretty cool. One day I'll show you guys. Okay. Now that's your GitHub account. You've created a GitHub account. That is your Git repository. So remember, do your best to try to associate the words. GitHub is going to be your Git repository, or it's a Git repository. Repository can get a little confusing because there's a bunch of repositories inside of this big repository, but they're all repositories nonetheless. But Git is a tool, so you might have to install it. So the way that you know if you have Git, I know some people were using Git Bash. That means you already have it. You can do this from your Git Bash command line. Go into your terminal or command line, either one. Go into it and just type in Git. Git. All you got to do, or Git version or whatever. Git version, or just Git. As long as it doesn't say command not found, you have Git. It should be available for you on Macs already. It should be available for you on pretty much all Linux distributions. On Windows, it is probably not available by default. But what you can do if you're on Windows is you can go here and you can download it. So just go to Git SCM, that's Git-source control management. All right, Civil, have a good night. Peace out. But head over to there if you're on Windows in particular, and it should give you a Windows link instead of Linux, and it'll give you like a whole downloader. It's really easy to install. Just click through and click the downloader. It'll probably give you Git Bash by default, and then you can follow along just as we're doing stuff now. But everyone else should pretty much have it installed already. And again, this is the technology you get. It's pretty dope. It's free and open source. You can actually go see all the code from it, but cool. All right, go do that. But let's talk about Git, the workflow. And is my iPad, let's see if this is gonna work. Let's see. Because we're gonna do some Git hands-on real quick, but I would like to show you some drawings first. Wrong one, whiteboard it. All right, so here we go. Oh, that does not set up how I thought it would be set up. Let's make this a little bit smaller. Smaller. This in the corner. Let's make this a little bit bigger. It's awkwardly sized for this. Okay. Oh no, this is a different tool, I think. Oh, I like this whiteboard tool better, actually. What tool is this? Okay. Oh, it's because I'm plugged in. Okay, excellent. So here we go. Oh yeah, if you're on Linux and you don't already have Git, these are some of the commands. If you're on Mac and Git isn't installed, even though it should be, you can brew install it. Let me go back over here, sorry. You can brew install it, brew install Git, or sudo apt install Git. Yep, that'll do it. And if you're using Chocolatey, if anyone on Windows is using Chocolatey, you can do that as well. All right, so back to the whiteboard. This is kind of the way that version control works. So the central repository, can you show some tricks to find what we want in Git? Yes, I can. After I do this, maybe ask some more specific questions, but yeah, I'll show you some Git tricks for sure. So brew, yeah. Oh, brew I Git, yeah. I don't use brew, so I guess if you can just do an I guess. But here's kind of how it works. So GitHub is going to be where your code, think of that as the central home for the code. This is where the source of truth of the code is going to live. And so I'll draw a little file here and a little code on it, and the code in there. All right, this is going to be your source of truth. That's going to be where the code lives. So kind of the way it works is you can use Git. Remember, it says it's a distributed version control system. So it said everyone who uses it gets a full copy of the files and the history of those files. So what happens is when you're ready to work on a project, let's say you just started at a company, and I can show you real time also. Let me log into my GitHub. I know you can't see it. Today I'm gonna remember to switch back and forth. But let's pull up something. So now this is a bad repo. Let's have a bunch of repositories. Let's go to Jack Black's Blackjack. We made this in the Python bootcamp. All right, so here is this repository. So here is actually so this project only has 2 files in it. A project's gonna have thousands and thousands of files and folders in it. So so this one's a little bit different. It's only got 2 files in it, but it is an entire code base. It is an entire code base, and there's Python file in here. There's a markdown file in here. So this is GitHub right now. This is the whiteboard. In the whiteboard, what we were just looking at is GitHub right there. That is the code base and the full version of that. if you join my company and this is the project that we're working on, what would happen is you would, from your little computer over here, this is you at your, everyone gets hair because you may be a man or a woman and both of us can have hair. And you're sitting at your computer, your little lappy toppy, that's a terrible laptop, and you're typing away. What you do is you go to the centralized place that this code lives and you grab it. You do something called cloning it. So that's the first thing I want you to write down is clone. And so I'll write it down, clone. And what you're gonna do is cloning, again, takes the full history of this file and it brings it down locally to your computer. So I'll show you what that looks like in Git. So let's do it hands-on. When you get into here to a project, when you find a project, I'll share this project so you all can do this with me. Right now you're paid in thank yous, I guess. Like that's all you get paid right now for my company. But what's up, Sammy Lives? What's up, J Towns? I've been loafing on the call outs. What's up, the solution 007? That's nice. 007. Pixel English, Metal Dragon, useful distraction. Nice. Starcross. I think reading you guys' names is gonna make me a better reader. To be honest, having to quickly decipher what's going on is important. Okay, so once you log in, I'm gonna paste this. Yes, we're gonna learn about Git init. We're gonna learn how to initiate your own repository. For sure, we're gonna learn that in a second, because we're actually gonna initiate our own repository. But I want to teach you cloning first, real quick. So when you do is you can click on that link, and over here on the right, it's nice and green because it brings you to something that's pretty important. And you click clone or download, and what you can do is we didn't set up the command line yet, but you can clone this. Don't do this part yet. I'm gonna do this right now just to prove a point, but don't do this yet. There's a setup I'm gonna have to do with you in a second. So we can copy this, and to get this full history of this code, I can go on my computer and I'm just gonna go into a different directory because it's gonna download all the stuff. I'm gonna go into deCoded. All right, so ignore where I just went to, but wherever you want to download it to, you can do a git clone. So I do want you to write down clone. So all the commands you're gonna be typing in are gonna start with git and then the command that you want to do. So git clone, and then you paste anything that you want to clone. When do you want to do this? You only want to do this when you want to, again, copy a history of files. You want to copy those files to the history of files. So what this is going to do, it's going to download that code base for me. And now I have this new folder called Jack Black's Blackjack. And if I look in there, I actually have the same two files and I can look at them if I want. And this is, oh, actually, what? Oh, this is even better. Perfect. I didn't even mean for this to happen. Wait till later. This is perfect. That doesn't have as much code in it as I thought it was gonna have. This is amazing, phenomenal. Okay, so that's how you clone it. Don't clone it yet. Well, you can if you already have Git set up, but first we're gonna start from scratch and get everything set up. But that's just the first thing because that made the most sense for my drawing. That makes the most sense for the drawing. So that's what cloning is. And again, that cloning takes the full history of those files. We'll show that full history later. Actually, I can type in git history. And, oh, sorry, not git history, git log. Okay, we're about that later. This doesn't have a history because, well, it does. On Monday, March 9th is when we pushed this code, so a while ago. All the code that we did for this is somewhere else, and I'll show you that later. Okay, so if you're using Git, if you can, I want you to go to, I want you to navigate in the command line, if you can, to the location in which you saved those files that we were working on before. So the variables.py, all those Python files and Go files we were doing before, I want you to navigate there. So if you still have Visual Studio Code up, you don't need to navigate there. All you need to do is click terminal, new terminal, and you can do everything from here. Ah, darn it. I thought I was gonna be on it. I got too confident. Thank you. Yes. So if you're in, if you still have your VS Code up and you never close out of it, or you can open up VS Code and click terminal, new terminal, and it should open up to where those files were. If not, I want you to navigate there. And an easy way you can navigate there is put your mouse over top of the file and it'll tell you the location that is at. So you can right click. So like these files, right click one of them and click copy path. Actually, that's what I want you to do. Right click, click copy path. So this will give you the full place to get there. If you're gonna do it outside of VS Code. And then what you can do is you can go here and no matter where you are, you can type in CD and then you can paste that path in. So to paste on a Mac, it'll be Command V. To paste on Linux, you have to do Control Shift V. And on, I think you can do Control Shift V in Windows as well, or you can right click on Windows as well. And so it'll paste that in, but don't hit enter. Just remove the name of the file. So you want the path, but you want it to the folder. So just remove the name here and it'll take you to where you need to be. It'll take you to those files. And if you do an LS, it'll show you the file. It should show you the files that we modified before. All right. So try to get there. If not, it's also not a big deal. You can use Get from anywhere, but I'd like you to try to go to where we were modifying those files. And so you're not going to have this many files. You're probably only going to have input and print and variable. All right, I lost you. All right, let's go back again. Do you still have VS Code up? If you still have VS Code up, you can do everything from here. So do you still have all your code here? What you can do is you can click terminal, new terminal. All right, cool. So just all you gotta do is hit terminal, new terminal. That's it, and then you can do everything from right here. Don't need to do anything else. Just make sure if you do terminal, new terminal, just type in LS and just make sure you see those files right here. So as long as you see those files right there, you're good to go. You don't need to do anything else. And that's all we have to do when we're on the same page. So nope, you don't see those files there. So it sounds like you saved those files at a different location. So what you'll have to do is open up one of the files. Like if you see the files over here, open up one of the files so that it opens up over here. So just double click on it. Yeah, so if you can navigate back to the directory, try to do your best to get back to the directory, or just find it on your computers. Perfect, you got it. So you can do, yes, you can do everything in here if you want, because this terminal is no different than your other terminal. All right, so the first thing we're gonna do is the first thing I showed you, which was cloning. This shows you how to get the copy of a Git repository that already existed, a code base that already exists. What we're gonna do is we're gonna create our own code base and history ourselves. So this is gonna be like us coming from this side. So this is alternative view there on your laptop. And so what we need to do is, while GitHub is a centralized place, Git works everywhere. So it's distributed. So Git is working over here, Git is working here, Git is working here, and whoever else takes it. So what you're gonna do is first, you are gonna create a Git repository. So you are gonna make this a repository. And so you're gonna take the code that you wrote tonight and we're gonna push it up to GitHub. So I want you to be here, but we're actually gonna go, I want you to be, stay where you are, but go back to your browser, to your web browser, and in your web browser, I want you to, if you're on this page here, I want you to just click your name over here and go to your repositories. So on the right, click your face and go to your repositories. All right. So this will take you, you probably will see none. If you just created your account, you won't see any repositories. It's okay if you haven't created a Git account. The concept is what's more important. You can do this afterwards, but go ahead and click new. This will allow you to now create a space for your code. It'll create a repository for your code, and it'll create a space to start tracking that data and that history. All right, so go ahead and give it a name. Call it whatever you want. Doesn't really matter. We'll call this deCoded Git. DeCoded Git example. We'll try that. Call it literally whatever you want. Doesn't really matter. This is required. Give it a name. You can give it a description if you'd like, just to explain what it is. Leave it on public. This is where you can choose if it's public or private. If it's public, anyone in the world can see it. Anyone with a GitHub, anyone in the world can see it. If it's private, only you and who you choose can see it. Leave it as public. And then there's this initialize with README. Don't click that right now, because we already have code. And yeah, so get here, just give it a name. All you gotta do is give it a name, leave everything else the same, and click create. And this is going to now carve out a space inside of GitHub for you and your code to live. So great. Now we have a space to manage our code. It's also, don't leave this page. It's going to tell you how to get your code here. It's going to tell you how to get your code from your computer to here, or it's going to tell you how to start using this repository locally. If you don't have any code yet, that's okay too. But we already have code. We have code that we want to push up here. So this is one part. What we just did. Oh no, the screen went off. Come back on. What we just did is we created a centralized place to manage it. So we created the piece up here for GitHub. But remember, although this is going to be the centralized place that we manage it, Git is a distributed version control system. So we also need to, because we already have our code, we need to also create a Git repository locally. We need to tell the computer that this set of code, these files, this place is a Git repository that I want Git to track the history of. Git needs to know what it needs to track. Like it needs to know what things to track. So we're gonna set up the space on our computer, and then we're gonna connect what's on our computer. We're gonna connect it to GitHub. And so that's what this is here. It says push an existing repository from the command line. So we're gonna set up our own repository locally, and then we're gonna push it here. So head back to your terminal. Head back to your terminal here. And actually this might already be a Git repository. Hold on. I might have to delete it. Oh no, it's not. Okay. So first thing I want you to do is to start to create a Git repository from your computer, to create a completely new one. You're gonna type in the command git init. So git init. This is short for git initiate. It's gonna git initialize. Git initialize. It's gonna start. Oh my gosh! One day I'm gonna get it. All right, git init. There we go. Git initialize. So this is the first. This is the first of 5 steps, and you're only gonna have to do this once. Every time you're only gonna have to do this when you start a brand new repository. So git init and just hit enter. And in VS Code, you just saw a bunch of stuff happen. So VS Code is nice because it has some Git integrations. We're not gonna worry about those right now. Just know it says initialized an empty Git repository. It does it right where you are. Perfect. Something happened. Probably feels pretty darn good. All right. What we just did again is we initialized a Git repository. Now, if you actually do an ls-la or just ls-a and you hit enter, there's a new folder here. I don't have Git master. Do you mean this right here? You shouldn't have this. This is something that this is a customization that I have locally. You don't need that. That is, I can show you all how to get that later, but that's just some stuff, visual stuff for me. So type in ls-a, you'll see that Git created a empty folder here. Don't need to do anything with it, but we initialized a Git repository. So we told our computer the place that we are now, I want you to start I want you to set up a place for us to save these files, to save and track these files. That's what the get init does. So write that down. Get init is how you initialize an empty Git repository. So that's one command you have. Now we've created a Git repository here, but we also have to tell Git. The term Git is not recognized in the name commandlet. So if you, this is one of two problems. If you're on Windows, then you may have to do this part in Git Bash, or you have to create a new instance. Try clicking the plus. If you just install Git, try clicking the plus here to create a new instance and trying it again, because it might not be loaded. Git might not be loaded in to your current session. Yes. The colors are a completely different thing, and you shouldn't have the colors. The colors are things that I implemented myself. I can point you to a video to show you how to do it, but the colors don't matter at all. But this is my terminal. This is my terminal right here. Yes, you can do this. You should do this. You should go to where you created those files earlier. If you created these files the code that we wrote, if you created even just one of them, you can do this. Even if you didn't create this, you can create some files after this. Just go into a folder, go into any directory, or create a new directory and type in Git in it, and it'll start up. It'll create a Git repository for you. It'll tell your computer that we have a Git repository. So after that, we can use another command. The most important command I'm going to teach you tonight is this one right here, which is git status. So git status, git status. Write that down and try to run it. It'll give you some information. It'll say on branch master. We don't care about that right now. We don't care about that right now. What we care about right now is it says untracked files, and it's saying that it's going to show all the files that are in this directory. So these are all things that we wrote. The example stuff was already there, but you should probably have the input files like input.py. So you'll have a different set of files probably. You will have a different set of files, but notice that these are untracked files. So Git is saying, hey, I'm a tool that tracks files. I see that there are files here, but I'm not tracking them. Do you want, basically it's saying, hey, I'm not tracking anything. These are the things I can track if you want me to track them. So what we have to do is we have to tell Git to now track these files. So this is the workflow. I'm gonna tell you the whole workflow right up front, and then we're gonna break it down. So that Git init that we ran first, that happens one time. You don't need to keep running that. Only when you're creating a new repository, run once. So that's not a part of the workflow. The part of the workflow is now. So git status is gonna be the first thing you always run. So git status, always get comfortable running it, run it all the time. It gives you information about what's going on. It gives you information about what Git is doing and what it's tracking and what's happening. The workflow is make changes to files, make your changes to your files, modify your code, do whatever you need to do. All right. Tell Git to track it. The first thing you do is tell Git, I made changes, track these changes. The second thing you do is you tell Git, I'm ready to save these files. This is, I got it into a state. I want to save a point in time here. And so save these files, save this point in time. What Git will do at that point is it'll create those patch files we talked about. So make your changes to your files. Tell Git to track your file. Say, hey, I made some changes. Go ahead and track this file. Save that change. Make a point in time snapshot of that file in Git. And then push that file to GitHub. Push it to the centralized repo. So that is the workflow. Make changes to a file. Tell Git, hey, I made changes to this file, so track it. Save the state of that file when you're ready. Like say, hey, go ahead and this is a point in time I want to save, and then push up to GitHub. All right, I'm gonna say it one last time. Make changes to a file. Tell Git to track it or to follow it. Tell Git that, you know, I want you to follow these changes. Save at the point in time. Push all that data up to GitHub. So we're gonna do that real quick. What does tracking do? Remember how we said that Git, the technology Git tracks all the changes to a file. It tracks the differences that happen between different versions of a file. You have to, for you to be able to get that information, you have to be tracking the file. Like you have to tell Git, hey, track the history of this file, track the changes to this file. So we're gonna tell it to track a file. So we're gonna do one file first. So we're gonna do the input.py. So we're gonna do git add. So run git status first, then run git add. Git add tells it to track. So git add input.py. All right. And so I'm gonna hit enter here. I want you, after every git command you run, after every single one you run git status. So run a command, run git status, run another command, run git status to know what you're doing. So now if we type in git status after we added it, check this out. It's now being tracked. So it turned green. It's saying, hey, I'm tracking this new file. You can run git add dot or star, but don't right now. We'll just do it with one. I'll tell you, I don't want people to get into the bad habit of running git add star or dot. I could run git add dot. This is probably what a tutorial will show you. If you watch a tutorial, it'll probably tell you to do this. Don't do this right now. It's a bad habit. It's a very bad habit until you know what you're doing. And yeah, it's a bad habit. So we added a single file and it says, hey, I'm tracking this now. Changes to be committed. Committed is what they use, is a term that they use for kind of saving that point in time. So right now, we're tracking the changes to this file, but we haven't saved it yet. So yes, the file is saved on our computer, but we haven't told Git that like, hey, this is a point in time in which to save the file. This is a new version of the file. And so the way that we do that is we do a git commit. And so it says it up here, get committed. This is how we save it. So we made changes to the file. And so let's mimic. Well, we'll change it afterwards, but this is a new file. That was the changes. The changes that it's a new file. So everything we put in it is brand new. And so we added it. We did git status to see what's going on. We added the file. So we told Git to track it. The next thing we're doing is we're saving this point in time. So with commit, you do git commit. You have to put in something called a commit message. So you do git commit -m. And so you want to tell Git what is happening during this change. So in this one, we want to say anything you want to be descriptive and say added program to display output. And it can be whatever. It's just a message letting people know what this save is, like why, like basically like what's happening in this point in time save, what things changed. So I hit that. Oh, okay, we forgot about this. This sucks. This is bad ordering and we're already over time, but still we're gonna keep going. So what happened is we got an error about telling us who we are, and this is actually good because you all would have run into this if I had this stuff configured. This is nice. So that actually might work for you already. We need to run two commands really quick, which really suck. If try to run this git commit command, try to run it because even if it fails, it'll give you the command that you want to run. We need to set up Git a little bit. I completely forgot about this. That's my bad. We need to set up Git a little bit to tell it who we are. We need to tell Git how to kind of identify us a little bit. And so just copy and paste these things. I'll paste them in the chat. Oops. I'll paste them in the chat. You want to change your username here, an email. So put your email right here, the email that you use to sign up with GitHub, and then put your name in here. So I'm going to paste this in. And it may work for some of you. You may be set up already, or it may use your computer name to get the proper thing. For other people, it will not work. So if it did not work for you, if it worked for you, you should still do this. Like you should still do it, but it won't hurt. So that's one, and this is the other. Remember, change your username and email. So I'm gonna do git config, whoops, dash global user.name Aaron. I'm just gonna do Aaron and git config dash global user.email. So I'm just telling git, I'm configuring my username and email inside of git. Hey Brooks at mastermind. All right. So now I'm gonna rerun that commit command that I ran because it actually never went through. Should I use the same email address for GitHub? Yes, you should use. So it doesn't matter, but you should use the same email for GitHub. It doesn't matter though. It can be. They actually both can be whatever you want them to be, which is something that's problematic about Git. They can really be anything, but make it the same as what's in your GitHub. Cool. So when it does work successfully, you'll get this little message here. And it'll give you a little weird little hash here, and it'll say the message that you typed. It'll put it in here, and it'll say one file was changed, and it had 2 insertions. So basically, it's just going to be a thing that this is where it creates that patch. You don't need to know where it is. You don't need to look at the patch. But if you made a bunch of changes, it'll say in here how many changes you made. It says 2 insertions because this file has 2 lines. So look at this file that we did. It only has 2 lines. So it kind of does it by line. So it says, hey, you added 2 things to this file. 1 file changed, you added 2 things to it because it's brand new. Okay, so we run through that workflow. We created our file, made changes to our file. We ran a git status to see what was going on. Then we told Git to track those. We wanted to track this file. If this is a file that we want you to track, Git. Then we ran a git status again to find out what was going on. Then we saved that point in time of that file. We saved that file. We saved the changes that we made to that file inside of Git by committing those changes. So we ran a git commit to save that. And then now we're going to run a git status. Git status. And so it's showing all the files that that we aren't tracking. But look how see input.py is not here. So as far as Git is concerned, you've done everything that Git cares about. So like you have now done what you need to do to track changes in Git. And all that stuff is saved locally to your computer. That the history of this file now exists on your computer. The latest history exists on your computer. What we want to do now is we want to get that stuff into GitHub so that other people can consume that history as well much more easily. So what we're going to do now is after you run that git commit and everything is looking good, all you got to do is head back over here to this page that we were at when you created your repository. Once you get here, we're not creating a new one. And so actually check this out. Yes. So this is what we did. This is what we just did. So look at the examples up here. We did a git init to start. We did a git add. We did a git commit. And then we need to run these last 2. And so really this down here, these are the same as these. All right. So we basically did everything that's up here. They just didn't do git status up here. So you can use this as a method. This is the workflow that people know from Git. People know git add, git commit, git push. Those are like the 3 commands people know. You only have to do this remote thing once. So let's run this command, git remote add. What this does is, like I said, Git is distributed. So everything you just did locally on your computer is like all the functionality of Git. It's already managed everything, but if we want to save our stuff in a central place, we have to tell Git where we want that central place to be. So what this does is this adds a remote place somewhere distant for our code to live. And so copy that in and just paste it on in there. You only have to run that piece once. you only have to run that once. Oh, actually I could have done it anywhere. Probably should have did it here just because that's where we've been doing stuff, but it's gonna give me an error because I already did it. So copy and paste that in. And so that's just gonna tell it that, hey, I want my stuff to be saved in this this space that we just carved out. And the last thing we're gonna do is we're gonna push this code up. So when and now git push. So git status to find out what's going on. Git add so you can track the file. Git status so you can see what's going on. Git commit to save that file's point in time. Git status so you can see what's going on. Git push to push the code up. So it's really git add, git commit, git push. Those are the 3 commands that you need to know, but I want you to run git status very often so you know what's going on. So git add, git commit, git push. Git add, git commit, git push. Track the file, save the file, push the file. Track the file, save the file, push the file. Track the file, save the file, push the file. That is the workflow, the basic workflow of Git. Git commit -m, type your commit here. But that's your URL though. So don't put it, so don't copy and paste in my URL. You should have gone in, so like you should have been doing, I want you to go to here in GitHub on your own GitHub account, click your repositories right here and create a new repository. And when you create a new repository, it will give you this information. So this is going to be the my Git repo, but yours will have something different. All right. So when you do push, check this out. Git push. Actually, let me do it out of here so you can see some cool stuff. Git push -u origin master. Okay, so it's going to this is interesting. Visual Studio Code. This is kind of cool. Visual Studio Code has some cool stuff. So it's gonna, now we got to authenticate. So when you push, it's not gonna let anyone push to your account. So you just got to put in your username and password. Whoa, this is cool. So if you're using Visual Studio Code, it looks like it has some integrations. I didn't know this was a thing. And it looks like it'll just allow you to authorize when you try to push. Okay, that's kind of cool. A little bit. All right, but for everyone else, especially if you're on a Mac, and you're not doing this in VS Code, if you're anywhere and you're not using VS Code, when you do that git push, it'll ask you for your username and password. It'll ask, and you type in your username, you type in your password, but it's actually uptime. Hold on. It'll ask you for your username and password. And you just type that in. It will not show you typing in your password. So don't be afraid when it's not showing you that. Like if I'm gonna make another change real quick. Not in here. Whoops. Hold on. I'm gonna do this in my terminal for everyone who is not using VS Code. I'm gonna add another one of those files. So git status. I'm gonna add print.py. I'm gonna add just print.py. I'm gonna do a git status. I'm gonna do a git commit -m. I added printing application. Sure. All right, and so now if I do a git push here, -u origin master, it's asked me for my username and password here. So now I can type it in. And when you type in your password, you see me typing right now, I'm typing, it's not putting anything out. It's gonna not print it out. So don't be confused that it's not typing. It is typing. It just doesn't wanna display it to anyone. So type in your password, enter, and it'll go through and it will upload. It'll let you know that it pushed stuff. And as soon as you do that, you go to your repository, and if I hit refresh here, I now have code that is here now. So now I have code that's here. So we'll go back to the whiteboard real quick. So what we did here is we created our code. So we created it. We then we tracked it. Create, track, save. And then push. And the commands for that are this was add, this was commit, and this was push. So whoa, that's what happened. So that is the flow. The flow is and then it goes around and around. So this user, say there's a different user over here. Now I should delete this right here, and let's delete the circle around here. Delete this. So that's how you got code into GitHub. That's the flow. From your computer, you create it over here. You tell your computer to track it with the git add command. You save it with the git commit command, and then you push it up to GitHub with the git push command. That is the workflow. That's the workflow. And then those changes that you pushed up, someone else, because they're all up here, someone else can grab those changes. This is someone else. They can grab all those changes with something called a git pull. They can pull all those changes, and the process can happen over and over again. They can make changes to the file, they can then track it, save it, push it, and then you guys can keep pulling each other's changes so that you can copy it. We will see this in action a lot, a whole lot over the course of this. Add, commit, push, and status after each step. You got it, Just Machine. Add, commit, push, and that will get your code up into GitHub. Make a change. So you can't add anything that's already been if there are no changes, you can't add anything. So if you already added all the stuff in that folder, you will not be able to add anything. So like if I tried to, so let's do this. I'm gonna add all these things. I don't recommend doing that. The dot will add everything. And I do git status, git commit -m, added all files, git push, and whoops, I mistyped my password. All right, so all that code is up there. But what I wanted to show you is that if you have no changes to be made and you do a git status, it won't show any of those files. There'll be no files that it shows. It won't show a file until you make a change. So if I make a change to one of those files, so I'm gonna change input.py. I'm gonna make a little change and call this age 1. I made a change to it now. And now if I do a git status, it says, hey, you modified this file, but you didn't stage it for a commit. So this is gonna tell it to go ahead and include that thing. So git add input.py. And then if I do another git status, it turns green. It says, all right, you saved this thing. We're tracking it, we're staging it to be pushed. Go ahead and save a copy of it. And I can say git commit -m, changed name of variable. All right, it says I went ahead and I changed something. I did change 2 lines. I deleted 2 things. I added 2 things because I changed those lines. And git push. And that's gonna go up to GitHub. Now, here's what's cool. If now it shows I have 4 commits. I have 4 different, I've pushed this to this thing 4 times. So now I have a full like a full copy of the history of all this code, of this entire repository. So I can actually see the changes that happen to input.py. So this is what it is now with the 1, with the age 1. But if I wanted to see the history of it and see what changed over time, I could go back and I could see, hey, what what was it before? And I can see everything that changed. These are the lines that were deleted. So this is what it used to be. And this is what it is now. So I can see that history. I can see that history there. So yes, that was a lot. That is the end of our base GitHub intro. I really thought tonight was going to be done in 2.5 hours, but I was sorely mistaken. But this is good. We're learning a lot. This is the first time we're running these things in the 8-week format. So we may need to adjust the time limits a little bit, or do like a 3-day-a-week class instead for the same amount of time, just to get the same amount of information in. We'll figure it out round 2, but I'll be cognizant of this as we get to some of the other things. But I hope you got something. I hope you got something out of that. I know it's a lot. Every week's going to be a lot. Keep fighting through it. It's not important that you understand everything we do at the first pass of this. When we get to the end, if you understood 50% of it, you now know 50%. Well, you really know 100% more than you did before, but now you know 50% of what we covered, and that's a lot more than you knew before. And maybe you have to brush up on a lot of those things, which is common. Every time I do an online course or anything, I have to go through on my own and pick up all the little tidbits that I wasn't able to get through there. So yeah, we'll create a branch next time. So we're gonna be using Git at the end. Oh, well, not the end. We're gonna be using Git every single class, every single one. So I'm not gonna do branch stuff now because we're already over time. People have already left. But we have 6 more weeks to cover the entirety of the Git process, which we will cover for sure. So what do we type in so it tracks the changes automatically? You can auto stage them. You don't want to auto stage them. There are ways to auto stage. You don't want to auto stage them. Why don't you want to auto stage them? Because when you are actually working in things, there's going to be times where you're working on multiple files at the same time, where changes are going to need to be made to multiple things at once. And the problem is, if you make changes to a lot of things and you're still working through getting something to work in one file and not the other, you don't want it to be staged. You don't want it to be tracked at that time. It's not ready to go yet. So you only want to manually include the things that you want when they're ready. Again, for it to auto do that, then you would not be able to push up things that were ready until you finished everything. If you auto tracked it, you couldn't be working on anything at any time. You couldn't have any works in progress. So you don't want to automatically track that stuff. I want you to understand how to do it from the command line, but you can do all of this from VS Code. If I make a change again, make it 2, and make it 2, and that gets saved. Check this out over here. It now shows a 1. It's basically saying there's one pending change here. So if I click on it, it'll show me what file changed. And so now it's ready to stage and commit. So right here, I can type in my commit message. I can say, change the variable again. Change the variable. Hit the little check button. And this will say automatically stage. So this is where you can click always. This is where you can automatically have VS Code do it for you. I don't recommend it, but you can. I'll click yes. And then now that stuff is ready to go. So it's been committed, it's been saved. I just ran the commit. Then you click the little thing here and you click push. And that did the exact same thing that you did from the command line, but from a graphical user interface. So that's pretty nice. So now if I refresh, if I look at this file again, the master branch, it will now have the latest code. And look at the message that it has. So push 25 seconds ago, change the variable with the message that I gave it. And now it says 2. So you can do that all from here if you'd like. All right. Tons of information. Tons of information. I thought that was gonna be less. Tons of information tonight. Hopefully you got a lot out of it. I know it was overwhelming. Okay, the first thing I told you, I'm gonna reiterate it every night because we had a big night last night on Horizons. Is that I want you to be uncomfortable being uncomfortable. This stuff is coming at you fast. You are learning right now what people take a semester to learn. You're learning it in 8 weeks with only 2 days a week. So it's okay. It's all right. Pick up what you can ask questions about the things that you don't understand. Do Google, do some research. Again, you won't become an expert at all of it, but you'll things will start to stick. Pieces will start to stick. Maybe you didn't understand the whole workflow, but maybe you remember today that, hey, I know that to create a new repository, I need to type in Git in it, and that's all you remember, and you understood that part. Excellent. You now know more than most. Git in it is how you do it, if that's all you remember. So don't sweat it. I know it's a lot. I'm trying to put together some motivation to keep you all going, because again, I do know how hard it is to go through this stuff. So just keep going. You got it. You can do it. Sorry I took up so much of your time. Next week, so tune in on Saturday if you're interested in pipelines. Pipelines is the DevOps SRE course. The concepts there are more advanced than they are here. We won't be going as slow, and not slow, but we'll be doing things faster. So we won't be. It's gonna be harder to just follow along with what I'm typing, because the concepts are going to be a little more important. What's up, Kangberry? Thank you so much for the Twitch Prime sub. Devo8, again, thank you again for the bits. But yeah, tune in for that if you're ready. Other than that, take the weekend, start to synthesize the information that you heard here, rewatch some stuff, go over the resources, watch a video on the stuff, watch some videos on these things, hear it from other people, start to try to submit the concepts before next week. Not that you need to be a pro at these concepts before next week, but just take the time, go over them, and get ready for what we're going to be doing on Tuesday. If not, I'll see you on Saturday or Monday. So cool. I mean, I make a mean stir fry. You've earned yourself a bowl. I appreciate that. So I love stir fry. It's phenomenal. It's one of my favorite things. All right, who we rating tonight? Let's head over to someone. Who are we rating? Let's see who is on first off. Night, everybody who's out. Peace. See you later. Thanks for sticking through it. Thanks for staying in there, staying tough. Hopefully not too sleepy. I'm sleepy. What am I looking for? Science and tech. Where's the science and tech section? Who we got today? Let's head down. What are people doing? Malware and C. Dynamic of the flu virus. Oh, CM Griffin. Yeah, let's head over to CM. CM's dope. He does some he does a lot of Twitch bot stuff. He does a bunch of JavaScript stuff as well. Yeah, it's cool. So this is Ubuntu. Only one Matt. It's Ubuntu with it's GNOME. It's GNOME. It's kind of default. It just has some customizations. Tweak. I'll just tell you what the theme is really quick. It's Mojave Dark, it's like the Mac style buttons and stuff, and the Chrome OS shell theme. So that's what I'm running. What happened to the rate yesterday? We rated yesterday. We rated Coding Garden yesterday. Yeah. Cool. So let's head over to CM Griffin. Say hello, CM. Raid. Pretty dope. Streamer. I think that's it. All right, got it. I typed it right the 1.5 time, the first 1.5 time, but cool. Countdown 5, 4, 3, 2, 1. Get some rest. You know, give your brain some time to relax a little bit, and I'll see you all later. Peace.